tool that is based on 3D apparel, and we want to move this as an interoperability into the games and also the physical production. And another author that couldn't attend here is Otten, and he is a CTO and the founder of Striker. And over to you, Carol.
Okay, so my name is Carol McDonald. You guys know me as the one who asked all the questions. So part of your task is, since I'm up here and you all are over there, you need to ask all the questions. I'm the co-founder of Nice Concept, and we're based in Washougal, Washington, which is near Portland, Oregon, which is on the west coast of the US. So, and our focus is mass customization of apparel and footwear. Okay, so why are you here other than it's scheduled? Basically, what we're trying to do is, what would it take to make a pair of jeans and a shirt, and to walk through kind of the process and where the gaps are and all of that. And we're actually going to divide this up into 3 sessions. One is the user data portion, one is kind of the design portion, and the third one is the manufacturing side. So it's easier to break it all down because you guys are going to have different questions related to different segments. Okay, so our motivation is to provide a framework for scalar modular unit 1. And did we define it on the slide, or is the next one we're defining unit 1? This one. Okay, so what is unit 1? It means that you're trying to make a garment that fits the person, and it's based off of the data of that person. So you're not making 10,000 size mediums, of which you probably only need 5,000, and then the other 5,000 get thrown away. No, we're trying to make 10,000 of one. So that's a totally different problem. And we're also looking to provide a theoretical basis for validation. But for the most part, we're basically just trying to identify the technology gaps and that inhibit the process of unit 1 manufacturing. So interoperability, you've heard this the last few days. This is still an important important aspect. So it's, you know, they have to cooperate despite differences of language, and that can be all sorts of language, natural language, computer language, interfaces, execution platform, whether it's on a distributed ledger. So basically the circles have to play with the triangles, that have to play with the squares, that have to play with the circles. So as you can see, that's the old round peg in a square hole, and we want to be able to go bidirectional with that and include the triangle. So on this one, the data capture and processing, you're going to get the customer data. That can be a raw scan mesh. It can be a data cloud. It can be based off of a phone app to an animation-ready avatar for virtual fit and sizing applications. And it's so virtual fit is meaning your shape. It's not just your size, it's your shape. Because everybody's you know, everybody's body is all very different.
Okay, so here we've got the graph of how we think this may go. So basically we are starting with the raw or synthetic data. We know we can capture body in different ways. It can be through the optics. It can be, for example, photogrammetry. It can be through the phone, which could be like a LiDAR. So it will be more of a machine learning also. But then we need to do some corrections because the scan will never be capture perfect. Then we will do some retopology because we need to make sure that it is for the web size. And then if we want, we've got those options of adding the texture and rig model, and they will help us with achieving the real body scan that looks like us. It depends from the need, as we will discuss. And then we've got the data storage. And throughout all this process, we need to account for the file formats, the metadata, and the privacy. And the privacy also include the client device, because it will include the customer order and the scan. So lots to do. So the first one, this is how we capture the body scan. And basically, when we arrive at scan, we have to capture the body shape and the anthropometric data. Anthropometric data means the body measurement. It's just a fancy word for it. And so when we capture the avatar, we've got a lot of missing points, and those points are important for manufacturing. So we've got the wrists, the armpits, the legs, as you can see on the image. So what we want to do next is to do the geometric correction of the surface. So we need to make sure that the mesh that the scan manufacturer, they account for the mesh assumptions that we do when we correct. So it's a body shape, it's a posture. How do we account for this? Because if I just use the template, how can I validate that what's real, what's synthetic, and how true it is to the user? So moving forward, we need to make sure, as I said, that it is in the size of the web, so it can be usable on the e-commerce site. We need to smooth all the data points that we have and the bumps that can happen. And we need to make sure that we preserve the silhouette that is true throughout the process. And the last thing is to adding texture. So the adding texture usually include the UV maps and normals. UV maps relate to all those seams that you have, that you can see between all the body segments. How do you map this? And the normals are for the light. So if the light is uneven, you will have another bumps, another artifacts in the scan. And then we go into the rig.
So part of what people like to use is to test the actual avatar. So they put them in a rig, which is actually also related to H-anim. We can borrow that rig. Thank you very much for providing that. But if you do it wrong, or if the other thing that people are finding is they have their auto rig, and you go in there and your auto rig may now screw up your mesh of your body. So if it comes in with one and the native pose is this, well, then that's going to change it. If the native pose is the arms down, that may change it. So you need to make sure that for apparel that you get to an A pose. So how do we make an A pose such that it can come through? Or how do we make it so that rigs, if I've got a rig, I can bring it on through and I'm not locked into a rig that doesn't work. So the other part is metadata. There's parts of metadata that we can determine that should be required. And one of them is simply the origin. So we make sure, and we know which way is X, Y, and Z. And X, Y, and Z is very important because any of the CAD that came from shipbuilding or things like that, the Z is in the positive direction or for your height. However, if you are in apparel, Y is the vertical direction. And so you have to make sure that you know where the origin is. You have to make sure that you know which way is up. And that is not an expression, that is an actual literal, I need to know which way is up. And then there's, you know, how you make it, who's got the copyright, what the difference between the data that you got from the customer, any synthetic stuff, what the file format is, you kind of figure that out. And then whether it's a full body or a segment, so full body has some requirements. If it's just the hand, if it's just the feet, if it's just the head. Hello? Hello?
Yeah.
Yeah, okay. Okay, so that was just a test. You guys are awake. Okay. And so it's also good, you know, to be optional is whether you get the age, the gender, or whatever. Basically, we've got optionals, which we may or may not get. People tend to be proprietary on all this kind of stuff, but we at least want to know where's origin. So that's helpful. So kind of in summary on here, we've stated the gap analysis, we've stated our requirements, And then kind of our goal is, planning for the future. How do we get to the future from where we are now? Are we going to be able to go to the other ones? So before we get into the thing on how you actually would work for jeans and a shirt, I saw it. We're actually going to introduce some stuff that we did at 3D Body Tech, the other one, sorry, that we just discussed a few weeks ago in Lugano, Switzerland. But we wanted to give you guys some background on this. Unless it's this one. Yeah. So she's getting there. Almost. Or I can just make it all up, right? It's not letting you do the second one? Or maybe I can just... There's always technical difficulties. Yeah.
Okay, keep it and just share the entire screen.
Oh.
Go back to Teams.
Yes.
And this one.
Okay. So.
I'm seeing sign in, and I'm seeing it. So basically in Lugano, for the IEEE 3D BP, you guys have seen that kind of on the sides is you're playing well with others. Well, we're one of the groups of the others. And so what we went through is what we've on the 3D BP, which is 3D Body Processing Group. What we've went through is we said, we need terms. We need to actually be able to define things. So we boiled down the whole ecosystem of 3D body processing to 4 assets and 16 transformations. And this is a little blurby. You can go on this website, feel free. This paper is on there, it's free. There's a bunch of other white papers. Feel free to wander off. Okay, so this is the 4 assets. So a human is you. Okay, you guys got that. A cover is anything that you wear. A humanoid is any representation. And a coveroid is any representation of a cover. Yep. So we went through and we said, what's a human? Human's a natural living person. And a cover is anything that you wear for any time. So one of the things that this helps is it's shoes, it's garments, it's jewelry, it's watches, it's whatever you physically put on your skin and however long you want to wear it. And it can be multiple layers. Yeah, that's fine. So humanoid is any representation. Now, this was really critical for the apparel market because they hadn't really realized that a mannequin is a representation. So we're able to say you have a 3D virtual representation and you have been using a physical representation of a human forever. So they finally could say, oh, they are the same thing. They're just in a different medium. And considering how many of apparel are still working with paper and pen, that was a pretty key thing to say, you've been doing it. Really, it is the same thing. So we had to deal with what are all the different humanoids. One of the things that, if you go from a point cloud and you change it to a mesh, it's still a humanoid. It's, that's the overall term. You guys have heard that a little. It can be static, it can be dynamic. It's a point in time, I've taken a scan, it's 4D, it's dynamic, it can be hard, it can be soft, it can have textures, and you can call it whatever you want under the sun. So, virtual humans, digital twins, blah, 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 and 1-dimensional, 2-dimensional, 3-dimensional, and that actually gets into the programming side of it as well, in terms of the pattern making, because a humanoid that's 2-dimensional is actually embedded in the pattern that makes the garment that fits you. So I'll just let you think about that for a while. And a coveroid, like I said, is any digital representation. This is actually a huge challenge right now because it can be hard, it can be soft, it can be created from physical or virtual measurements. It can be a shape only to a shape only with material properties. It can be a tech pack and single layer, multiple layers, components. It can be assembled or unassembled pieces as well. And these are the transformations. So some of them can be irreversible. If I go from a human and I scan it, I can't go back from a scan to a human being again. That's probably way in the future. So we have covers can change. You can modify them. Humans move, in case you want to know how you can transform a human. Humanoids, we can change their state as well. Coveroids the same way. And then some of it's just the viewpoint, i.e. you can look at the humanoid and you can say, how does that relate back to the human? Some of them are definitely going from a virtual. I have a coveroid. I now make that into a garment pattern. It now becomes a cover. It goes from a virtual to a physical world. So this is our whole world in a nutshell, and we tried to just kind of get a whole environment on it. And this is the paper, this is where it's located, and this is all its little technical information. So we'll just skip out of this. Or we can go back to the presentation. Yeah. So it's not 100% smooth, guys, but I think you're okay. So let's go back to, yeah, that's the one, page 6. So basically now it's the part of, do you guys, do you have any ideas on how to get from here to there? You have any questions or the need? So this is the interactive workshop part. Oh, are you, anybody awake?
Stress on interactive.
Yeah, stress on interactive. So think about you wanting a shirt. What would it take? So you take a little phone app, you take your picture. Usually you're not dressed in your full clothing. You're dressed in undergarments or some tighter garment that doesn't overly compress, that just basically you can get the shape. For women, it's actually important to be scanned in the bra you intend to wear for the product, because the girls will move and then you have to make sure that it's the appropriate one. Yeah, that gets embarrassing talking in front of your male peers, but the joke is they're the girls, okay? So if you hear me say that, you know what I'm talking about. And then from there, we have to make sure that, you know, it's what we want, or how do we relate that? Now, a lot of the phone apps are doing what's called, they have a synthetic human in there, or humanoid, and they match you as close as they can. Now, and you're like, well, how does that work? Well, sometimes it works really well. If you're an outlier body, it really doesn't. It's really strange because you go in there and you're scanned and you're like, wait, I have no hair on my avatar, because they just grabbed a synthetic one, or you have your hands out like this, and sometimes you make a fist and sometimes you have fingers. Those will change. And then the texture is important as well, because sometimes you want to go to AR, VR, and you want it to look closer to you in terms of your hair, in terms of your skin tone, but other times you don't. So for measurements, you may or may not even use a texture layer, because you basically just want to get the shape. And then the rigging, we're going to go into detail onto the rigging as well. And then, of course, there's data storage. So is it on your phone? Does it, once somebody actually takes a picture of you and they've done this change, is whose data is it, right? When does it go from being you to not being you? And so there's all the privacy issues as well behind that. So.
Any thoughts?
Oh yeah, I bribed her to ask a question. Can we get her the microphone? It helps to pay people off before the episode. Anyway, your session.
Thank you. No need to bribe me because I'm actually a bit concerned as a girl about sending photo of me in underwears. Maybe boys use the same, but no, you're fine. Okay, then only girls then, girl problem. Upon the privacy, or you said also you have to have the specific bra you'll be wearing. I don't own one single model of bra. I don't know for you guys, but so is there a possibility to? I know the idea is like to have the less possible clothing so we can try clothes, but isn't there a possibility to not send almost nude photos to have our avatar clothed?
Generally, what the other thing that people are doing is you wear, if you want to wear a garment, it needs to be very not compressive, but form-fitting. So that's a very common thing. I know when I was in there, I got some yoga pants because I'm like, there's no way in hell I'm going in there and taking a picture. So I now have kind of my scan clothes that are form-fitting enough, that are conforming to my body enough that I don't have to stand there in the birthday suit or birthday suit plus a swimsuit, if you know what I mean. So yes.
Yeah, so that's an interesting challenge, right? The whole idea that we could do some of this at home, maybe versus like in a shop where this might be protected, or we might have some equipment that is given to us from the scanning, more like a on-location retail kind of a thing first. I don't know.
Would you trust the retail?
Well, I don't know.
Well, you get in a changing booth, right? I mean,
Yeah,
you
there
do
would be
get down there, whether you might change really quickly, but you are in there in the store. So is it any different or not? That becomes.
This was, I think, the one of the key things that Chris Lane talks about a lot, right? I mean, there's what happens with that information, and immediately it's sort of compromising, in different ways. So I think that's a big one. I don't know if folks have other thoughts about.
So one of the thing I know, like SideStream does, is the processing is all now occurring on your phone. And so after it's processed, after it's de-identified, it's sent up. So it depends on the supplier, but that's like the key thing, because people are like, not only do I not want to give you my credit card, but I sure don't want to give you my body. So that is definitely an issue.
Please, yeah.
Thank you for this wonderful presentation. It's very inspiring, lots of applications. I was wondering if I could get my own body, not only for clothes, but also maybe for different purposes like health, or maybe for artificial life, of course, metaverse. And what would be the consequences according to you? What do you think of that?
Can I just?
Yeah.
So the scan presented here is actually from the gym purpose. So this is one from the Fit3D, and they are very popular in the gym and fitness. So if you want to track whether your diet works or whether you actually gaining something on a very specific part of the body that you're trying to model, this is pretty good way. It's still not perfect for the clothing because it needs much more details. But if you're monitoring your health or more like a fitness tracking, this is good option. However, this is only 15K OBJ. This is what you get in the standard retailer. So if you want this kind of Hollywood After Effect animation, you need to really go into photogrammetry, and this one is structured.
Yeah, so for the AR, VR, there's different levels of standard fidelity that you actually need depending on your application. And that's actually one of the points we're going to be going into as well, is that it really depends, right? Because I can be close enough on your VR AR if you're going to be in a room like this and you're now showing off your avatar. But if I'm actually going to make you a shirt, I need to get much tighter and much closer to who you actually are, and not something that looks kind of like you. That's well enough that I can tell who you are, but it's not actually useful for making clothing.
This is also why, like, Unit 1 manufacturing scanners or the public scanners, they will not put much attention to the face, so the face details never gonna be very precise. Whereas in like photogrammetry, you get this face detail to the very, very fine detail level of detail.
Yeah, and you can, that's part of de-identifying is you may make a closed avatar, but the face is gone. So you don't know who that person is.
Any more questions, or shall we move?
I think
Ready
we
for
can
next
move
stage?
on, yeah. And I'm sure if we get done a little earlier, nobody's gonna mind a 5-minute break.
Hey, so now the next question is, so we've got anthropometric data, and what do we do with it? So how do we absorb this data from anthropometry? How do we absorb this data from also clothing? Because as we heard in the previous speech yesterday morning, it is actually really difficult. So the graphics are slightly more complicated. We can take the avatar as a starting point, but we may decide whether we want the rig one or the texture one, or whether we just want the retopologized one. So then we have to start with the garment properties. So we have to find a way, we don't know yet this actually, how to get the digital equivalent of the physical garment. So what are the properties that I need to measure from the both aesthetic perspective and the mechanical properties? And how do I translate them? How do I save them as the information to be actually useful for the developers? Then we've got the visual aesthetic, and it may sound banal that aesthetic is important, but we actually have to find a way to quantify all the drapiness, all the seams, zippers, because they actually add the weight to the fabric. And then we have to render the fabric, which is very difficult right now, and I will talk about those details. But then as we add all those details, we have to not only have the avatar, but also the landmarks for avatar. So there's landmarks for the garment, there are landmarks for avatar, how do they relate to each other? Then we have to add the fit parameters, and they are both objective, which what is the designer intended fit, but they are also subjective of what is customer expecting the garment to fit, because we may give them the best fit and they will still not be happy. And then we have different kind of outputs, but we will go through them through the presentation as well. So, and obviously privacy, metadata, file format are still very relevant. So the first one is the digital equivalent for physical properties. So we need something like the textile database that we can reference. So I listed all the mechanical properties here for the fabric, and as we can see, it's quite a few. So there's bending, there's stretching, there's shearing, there's friction. So we need to find a way to capture them in an open format, and so other people can reference the same. So the jeans fabric, it's the same for whatever company is using this. So how do we encode this, and how do we reference this for the developers? Then there is the visual part. And again, I've listed a few things. So we've got the drape and also the color, the luster, the texture data of the fabric. So we may have a cotton, but the cotton can weight different depending whether it's a blend of something or whether we want to make it a jeans or whether we want to make it a summer blouse. So the fabric itself can vary. We just have to account for this. And we need to find a way to combine the mechanical properties and aesthetic properties. So wherever we add some aesthetic, it is reflected in the mechanical properties. So there is a symbiosis between those two. And then thirdly, and this is, I think, the most difficult one, is how do we render this? Because right now we have a lot of problems. And one of them is that fabric doesn't stretch or bend in just one way. So there's no linear deformation, and we still cannot figure out how to do this and how to account for all the properties, not just one. Then most of the fabrics that you see in the games, as it was said yesterday nicely, are like a spandex. So you wear something very close fitting. And it is because we don't know how to account for the non-elastic properties. So if you try to do something that is not elastic, it will not look realistic. And then we have to adjust the color and the brightness depending on the fabric. And this also depends very much on the camera position and the location. It's also quite tricky. And then once we've got this, once we've got all those 3 stages, we can start the assembly process. But first, we also have to account for the user data.
So just to give you some background, because I'm sure none of you here are pattern makers. And that seems to be a very correct assumption. Okay, so we actually have what's called landmarks on your body. You tend to use those things, very simple ones, when you go for your pants or your shirt. For women, you tend to give the waist, the bust, and the hips. For the men, you tend to give your waist and your inseam. Women actually need different inseams too, but we're not allowed. But anyway, what this is showing is that, yeah, here you can see I have different landmarks, and what's actually needed to make a garment is a lot more than this, because I need generally, I think I'm trying to think, but if you really want to get something closer to bespoke, it's like 100 landmarks off your body, Let's get the back. Let's get your thighs. Let's get where your knees are, where your ankles are, where your elbows are. All of that makes so your shirt and your pants actually feel comfortable. The other one that we had was the definition of hips. You would think we know what hips are, but we actually don't. There's a low hip, there's a high hip. One of the simple ways is, for example, how to actually define where your buttocks is. You think, well, I know it's the spot out here, but actually for pattern making, you have a little flat zone in that curve. And so you don't just hit the max point, because that's going to cause you problems. You say, well, I want everything in that depth that's about 1 millimeter, 2 millimeters. Now find that whole zone. Now give me the center point or the horizontal of the zone, and from there I can now make those pants correctly. So if you just say I'm coming from the top or I'm coming from the bottom to actually find the max buttocks, you're going to get the wrong location to make those pants. So it's like, who knew? But anyway. So fit parameters, one of the things, so this is actually rather tricky, and I'll tell you why. Because people have different opinions. You all don't agree on what a loose fit is, what a tight fit is. The other thing that people do is, well, I actually like my thighs or in my pants to be a little bigger, because then it balances out my little tummy. Well, if all I do is say, okay, everybody, once I've measured you, I only add 1 centimeter of ease in the front and the back, and you actually prefer to have your legs on your pants to be a little wider to balance out your body, you're going to put those pants on, you're going to go, that looks really bad. Okay, so we have to understand the aesthetic requirements to all of this when we set up the parameters, and we have to put in guidelines that say, oh, if this ratio is a little off, you are a little different than if somebody's not an Olympic athlete, you actually may want to adjust it this way or that way. So even though you might say, oh, it's just this offset, well, not really. We lied. So now you also have to deal with assembly. So assembly is important because every time you introduce a seam, you change the material properties. So think about that. So, and how you've sewed it, you've changed the material properties in that location. So you have to understand the direction of the fabric. You have to understand the assembly. you have to understand what on this. So I'm actually going to send this to some poor manufacturing place to make it. Well, we've all decided we're going to do jeans and a shirt. So there's certain parts that are going to be standardized. It's the same material, it's the same general pattern, et cetera, but I also have a customized portion of it. So an easy way to explain that is if I'm somebody that's 2 meters tall, I actually may want 7 buttons on my shirt. If I'm somebody who's only 1.50 meters on the shirt, I think that I said that correctly, you only may need 5 buttons on your shirt. So you actually have to understand what changes based off of that customer's data. So in summary, we've actually said, here would be some of the requirements, a consistent vocabulary of fit and ease. Not only does everybody have their own opinion, you have all different languages, and that it keeps adding. So we have the non-elastic materials, we have the deformations, drape. So a really hard thing to do is to tell the difference digitally between the drape of silk and the drape of wool. So if anybody can figure that one out, there's actually quite a bit of money still on the table for that one as well. So they do have exchange databases that are starting to link up that you can say, this is the material, here's my MOQ, here's all of this. But you have to regenerate that material from the physical to the digital. And how does that actually happen? And so all of that's being worked on. And like I said, we have to do a clear definition between what's a standardized and customized tech pack. Oh yeah, we should, because we did rigging in this one, didn't we? Yeah. Yeah, so we're gonna show you some other stuff from the same Logano presentation that we did. So this one is between rigs and humanoids and coveroids. The reason why I did that first, this is the whole universe, is because coveroid is not something that you guys are familiar with at this point, and I thought we should define the words before we move on. So that's the same slide. This is who we are, blah, blah. Okay. So why do you want to rig them? Well, one of the common things is you do the catwalk, right? Okay. But the issue but you also have things like, I want to ride a bike. Takes a slightly different rig if you're going to ride a bike. And you want to be able to support the customer's decisions by showing virtual try-ons. You also have to understand the body itself, and then you want to relate that. So we went through and said, here are some of the tools. Here's kind of our definition of fits for the background. There's the fit occurrence, there's the preference, there's a tolerable fit. You will wear the sweater from grandma even if you don't really want to, it may not fit you perfectly. There's a fit deference. Oh, if this is what's in this year, I'm going to wear that, even though maybe you may not look good in it, but it's your opinion. Learn fit. This tends to happen a lot with footwear. I only come in certain widths, so you're just going to have to learn to shove your foot into that shoe. Optimum fit, the ideal fit. One of the things that also means is that fit preference depends on the season, the trends, the activity level, the age, the fabric properties, the environment. So, something can fit you really well when it's cold, and when it's really hot, you're not going to wear it. So we have a fit example of bras. We had one of the authors in this paper go through that. People kind of know when they don't like something, but they don't know how to correct it. That seems to be an issue. The other thing is your body ages. Gravity is not your friend at this point. So about every 7 years, or if you have a life event, you get an injury, you have a baby, your body changes. You're going to need to get rescanned. It's not one and done when you're 20, just to let you guys know. And so you may actually need, garments are part of the wardrobe. The other thing, especially for bras, is they impact the fit of the next layer up. Your underclothing, whether you're wearing Spanx, impacts what you're doing next. So if you want to wear it with, you need to know what you're doing. So this was one of the examples. The modeling. Yeah, so what we found right now is the mesh construction is rather painful. The skill level, it's highly dependent on who's doing it. The animation rig, you've got joints and segments, you've got the skin, it's got measurements, the spine. We've determined the spine is related to just about everything else. And then, so in this presentation, we actually modeled the spine and said, what do we truly need? And the issue with here would be really nice is that if something's got an auto rig, it may have just screwed up the rigging that you just did because it's going to override your perfect rig. So we had some different examples that we had. Here's the ISO HANM, which we greatly appreciate. And we mentioned you guys more than once. This is the LOA2 versus the LOA3. For the spine, what we determined is, and the LOA4 is pretty much the same on the spinal area. We pretty much determined that, yeah, we can use an LOA3, but we only need some of them, but we need more than the LOA2. This is another thing. One key thing is that you definitely need to have a right and a left. You all are not symmetrical. I just thought you'd like to know that. It's kind of a shock to the system, but you definitely need the left and the right, and that you actually need to divide things into segments because that may be as close as the clothing can really handle. This is one to show, this is the age, this is posture with age. So for those of you, if you make it to 90, sorry, this is what you're gonna look like. And so how do we actually get enough spinal joints such that we can model an aged body as well? And then we also have sometimes what people will do is they kind of lean you a little forward in your avatars. Well, that's not really what you need. So how do you actually align that to what people actually do? And then one of the things that we're finding is that if the default mesh in one software is this, I don't know why, but anyway, it is, or if it's a T pose, or if it's straight arm, is how does that change the surface area when you now change it to an A pose, which is a standard that's utilized for apparel making. And then some of the methods on how you make humanoids don't mention the fact that you want to wear clothes with this. We kind of need that for apparel. And then this is actually showing the details on how the neck is the balance and how your collar actually looks based off of whether you can model the neck properly. So I think you can just switch. I'm doing this one really short. The other issue is that if you model the neck, if you then change it to model the neck with it's too limited and it's locked in place, you actually deform the front side of the mesh. And so you're not getting correct information there. So kind of the takeaways is digital product creation really needs help with the rigging and the mesh, and that we need to actually use some the spinal joints to help us out with that. And then from there, you know, that the limited spinal joints may be fine for marketing, gaming, AR, VR, but when I'm actually trying to make a product to fit on you, I need to have a little bit more joints. So that was this one. Just I thought that just trying to have you guys see it without these background presentations, you're like, I don't know why you care about a rig. And this kind of helped. So we're going to go from here. I guess you can go back to the Is
The
it?
diagram.
Yeah, that one. Yeah. So
Any questions?
any questions? It's now a workshop again. Anita's got a question. Oh, and if there's been any online, if anybody's been paying attention to the chat, if you guys could let me know too, that'd be awesome.
Oh, by the way, great presentation. I guess I'm thinking of, when there was a time when we would go to a seamstress, measure, and we would get custom made clothes. And then we started going to the department stores and buying something that was our size. Sometimes it fit, sometimes it didn't. But we have several choices. And what you're trying to do here is try to get this perfect fit. So there are so many factors here, right? Aesthetics, ease, how do you want to fit this garment on your body? There is material, there's draping. So do you see a standard coming out of this, or maybe just best practices?
Yeah, and I actually wouldn't say that it's perfect. It's a more optimum fit, right? If you're truly going to be perfect, you're doing bridal wear and you're going to be back and forth 7 times before you get it fixed. But for every day, I don't see it. So as a standard coming out of this, I would say, can we use a best practice on a rig? That's actually really huge because right now everything's rigged differently. How we can make a rigging such that it's interoperable to Clode, to Browseware, to Lectra, to all of that. And they just go, this is the apparel rig. We dump it in. And if you want to add more nodes to it, you can. And it won't impact the mesh, right? I mean, that alone, that's defined the humanoid side. For the coveroid, I see things are coming, but how you handle assembly and how you handle seams and all of that is still a big to model it, right? And it may be that you don't have to model that seam correctly as long as you've got it where it drapes so it looks like a real garment, right? So you may not have to go 100% there, but you may get closer and it'll be enough.
So where are you guys today? I mean, how is the garment industry handling it now?
It's called paper and a pencil. Really, and it's called fit models. So we have custom garments for the 5 fit models, but we don't really know. We know that you purchased that garment, right? Amazon knows that you bought that shirt or that sweater, but they don't know why you bought that sweater and they don't know how it fits you. So
yeah, it's worth to mention the sustainability aspect in all of this. So right now, fast fashion is actually not something we can optimize to get a better result. We need a different way of doing things. Otherwise, we actually using too much of planet resources. So it's also good in mind that we really need to move forward with something different than what we're doing today.
Because right now, I mean, if you look at it, the one reason, I mean, and returns, they're starting to clamp down on returns because people are doing thing called bracketing. That means I buy a size, sorry for you in Europe, but I only know American sizes. I haven't bought European clothing. So I buy a size 10, for example, and I buy a size 12 because I don't know what's going to fit, right? I order it online. I now send it to my home. I put it on and I go, oh, this one fits. I'm just going to send this one back. It's now back in the reverse logistics nightmare. And it's billions of dollars, which is why brands are starting to go, we're not going to accept returns anymore. You're just going to keep it. You're going to go, but I don't need the size 10. That's not their problem because it's cheaper to not have to deal with it. So you get to throw it away instead of them. So you just look at the sheer volume that we've made that we don't need. And it's because everybody's taken a wild ass guess as to what's going to fit you.
So my other question is about H&M. Oh, go ahead.
Sorry, I just wanted to say that if you actually go through the process, you invest some time, you may build this kind of emotional connection with your garment. So you may not want to throw it as much as if you bought something on a sale for $3. Because you actually put some effort into it. and you feel like it's for you, it's personalized. There is the whole social science aspect coming along as well, unexplored yet.
One of your slides, you mentioned that you need more joints and more points in the H&M model.
Oh, it depends on which version. So keep going back. It's in the other one. Sorry. Yes. So we looked. So on this paper, we were focusing on the spine. What we've determined is we need a subset of those on LOA3. We don't need all of them, but we don't need all 7 on the neck. But by God, we need 3, and 3 works really well. Okay, so top, the center, and the bottom. Okay, so we could use a subset of that. The LOA4 gets into the details of the hands and the feet and a few other things. So we can use a subset of what's already existing for you get from H&M and say, for best practices, here's what retail can utilize.
Okay, good. One last question about OBJ and file formats. I think you mentioned it.
We will get
somewhere.
to that.
Yeah, and that too. Yeah, we're still here as well. Yeah, our OBJ are our friends that we'd love to get rid of. Sorry, that's just a personal opinion.
So we have a question online. I believe Don's raised his hand.
Yes.
Do you have your mic active, Don?
Yes, thank you.
Okay,
Really
super.
impressive. The level of detail you guys are getting into and the precision of the terminology. So it's super. Carol, you're exactly right that when we went from LOA 3, level of articulation 3 to 4, all we did was add hands and feet. And none of it locks anybody in. It's just progressive levels of detail that match the actual segments and joints in the human body. So it sounds like there might be, I don't know, an LOA 5 or just a whole different vector of what are the points on the body that match clothing, and they might not be exactly identical or symmetric to the skeleton, but they might be complementary. They might cover it satisfactorily. So I think this is all very promising.
So we actually have that's in kind of process. We sent something to Anita ahead of time, and she's like, wait for the conference to be over. So basically the plan is, because we're actually going to overlay what's out of ISO 8559, which is the landmarks needed for clothing. There's ISO 18225 or something like that. That's actually the virtual ones as well. They don't quite cover enough for apparel, but we can line up like 3 different ISO documents and say best practice for apparel will be X, and it's a subset of this, and then we can, kind of the goal is to be able to go to, like I said, browse workflow, Lectra, et cetera, and go, can we put in this rig to really help us out? Because the goal of clothing is not to just walk on a catwalk. I know you guys do more than just walk on a catwalk. So we need to be able, and we also need to be able to deal with the asymmetry, because a lot of times it's like, well, isn't the right the same as the left? The answer is no. And how you deal with aging and how you deal with different postures and all of that, scoliosis, there's just all sorts of things that if you had a few more, you can, and the tilt of the pelvic, I mean, it goes into incredible detail. So I think we can, we just need to filter out from LOA 4 what we truly need.
But just to mention that if you disable, or you've got, like Carol mentioned, scoliosis or something, it is nightmare to find the correct clothing for you. So you often have to compromise on something. So if the t-shirt is too big, that maybe at least my sleeve length is going to be too all right. So there's always this compromises going on. So when we do the rig and stuff like this, we also have to make sure that it's accessible, not just for the small population, because then we're going to just do the same thing that sizing does. But we actually account for all those disabilities that comes and that didn't have the chance for a good fit yet.
Thank you.
So I think, is there any other questions, or do we want to move on to the section 3? I think we're on to section 3. I think silence means they're slightly awake, but not quite. Okay.
So the third one is the most fun one, is the manufacturing production. So once we've got the anthropometric data, once we've got our tech pack ready, and we've got all the assembly information, what do we do with it? Because we all know that manufacturing and clothing are the ancient crafts. They came with the human beings. We always had clothing. It's not a super new invention, but the manufacturing, it's kind of behind other stages. So normally this has to be a very bi-directional to work. So at the heart, we've got the PLM and RRP systems. And those means PLM means product lifecycle management, and ERP means enterprise resources planning. Then we go through the logistics, smart tools, digital assets management.
Yeah, it was your word.
Distribution centers, and deliver product to users finally. And I suggested also to put the blockchain because, but it doesn't have to be blockchain. It's a new buzzword, but it's kind of useful for the stuff like this, but it can be any other networks that is secure. And then obviously still file formats, metadata, and privacy, because the information will travel. And if I want to order a t-shirt, I don't want to find my anthropometric information somewhere else sold. So the first one is PLM in IRP. As I said, this is the heart from where the information go. So if I go back for a second to the graph, it shows here that I need to make sure that when I've got the order, I can check with the logistics that the order can be handled at the place, that there is enough skills and resources to do it. Then I have to send the instructions to the smart tools. So whatever garment I'm working on, I have to make sure that I've got the machinery that can read the instruction and can do the tweaks. Then I have to send the feedback to the digital assets management. So this is the portion that will do the QA for me. And basically what I want to get from here is the bill of materials. So I want to make sure that I have the variable quantity established, that I have the instructions for my smart tools, and that I have the requirements for the localization. So if my customer is in, let's say, France, but my company is from US, I want to make sure that I have the manufacturer in France close to my customer. So we go with this ethos of we've got the global design, but the local manufacturing. So we have to make sure that we can track the IP, that there is the data sharing and copyright protection in place, that we've got the logistic requirements so that the manufacturer can actually send the production to be streamlined and the service to be delivered. Then I have to go through my smart tools. So as we know, there are different tools for different purposes. So I listed a few here. We've got for the fabrication, we've got the printers, the dyers, the cutters, the assembly engines, the coordination computer environment devices, etc. And there is this customized portion of a tech pack. So as a manufacturer, I cannot only handle the general portion, which is standardized, but I also have to account for all those tweaks that my machinery will have to do as I do different sizes, because it will be very different if I do size 4 or if I do size 24. So I have to make sure that I've got enough room and agility really to do this. And at this stage, I actually should have my garment, unit 1 manufacturing garment created, but this is not really the end of the process. So I have to then make sure that I deliver the quality that I promised. So I have to do some testing. I also could do the recycling if I can, so I can monitor if there are any defective components and if I have any dye that maybe is not, it needs a special recycling, etc. So all of this needs to be handled at this stage. So this is like something very new, because right now when retail deliver you the product, they don't really care what you do with it. But if we care about being sustainable and actually doing the whole recycling cycle, so we don't just want to dispose the new garment to the landfill, we really should account for the post. How do we handle the garment after it is sold?
So one of the things, for example, that Amazon has done is developed amazing amount of square footage for distribution centers, especially in the US. It's absolutely amazing how much they bring it in and they send it to you. So one of the thoughts that we had, what if I put a manufacturing place near some of these key distribution centers such that it's next door? We can also offer the people who work at Amazon, we can upscale their skills a little, and they can, and then they just send it on to the nearest distribution center, off it goes, so that we can actually say, how can we use this infrastructure that Amazon has put in millions of dollars, and I'm sure it's with a B, and I'm sure it's euros, dollars, and any other currency that you'd ever want to mention. How do we use those so that we can actually, in Amazon or anybody else, how can we actually use those so that we can manufacture right by where it's actually going to be shipped from? So if you're in the US, one of them is like the UPS or FedEx is in Kentucky. They have tons of manufacturing that's right around that. And they just sit there and go, oh, yeah, it doesn't have far to go. And it just gets sucked right into the system. So that's one of the things, is how you have now global distribution, global manufacturing. Because the good news is about this is I can ship material, but I haven't shipped finished goods. And why does that matter? Because I may buy quite a bit of material and say, yes, I know you're gonna sell 10,000 units, but the goal is so that I can sell it at full price. So I'm not gonna run out of size 10s and 12s. I don't know what it is in Europe's, whatever the standard size that always runs out within the week after they put it on. And then there's the gazillion extra smalls, and there's always a lot of extra larges, and you're going, why did you guys even make these? You didn't need to. You could have made 3 more that are in the standard size zone for one of the really extra large ones and made money, right? I mean, the key is, as a manufacturer, you can actually avoid sales if you actually make things that people can get at full price that actually work for them. Anyway, just think about that profit. Okay, anyway. So then it's the consolidation, right? Because there's going to be various providers, and how you get, so the goal on this one is, I'm really trying to make perhaps a global manufacturing and maybe a local design, or I make a local design that's now available more globally. So, maybe in Nairobi, I have a really great designer that I can now make those designs available globally, and I can manufacture them in the areas in which people want to buy them.
Just think how this will reduce the carbon footprint.
Yeah, that's just an advantage. So basically, we're trying to make sure also that there's no data leakage, that the security, right? Because once you ship it back to the final customer, you've joined that personal data back together again. So you've separated it while you've done the design, you've separated it while you've done the actual manufacturing, but for the actual distribution, you bring that back together so it comes to your address. And then you've got, clearly multi-source data. So how do we make this all work? How do we fit this in? Where does, Web3D fit in this with an ERP system and a PLM system? That's just plain nasty administrative stuff. But anyway, really needed. So where are we next? So this is the entire pipeline. So one of the thoughts is we'd kind of show this one, and then we'd go on and say, do you have any? Oh, yes.
This
and here's
the file format.
Yes.
So this is the most fun bit, because we can see how many file formats we have to go through. And if you worked any part of the manufacturing, you know that a lot of those don't like each other. So we start with So this is how the industry works now. So this is just one of the examples of the data, how it is traveling right now. So if we go through the scan and we want this very, very raw point data, this is a VDRL. But then if we want to add the mesh, it's usually OBJ. Sometimes it could also be STL, but that's more like 3D printing and figuring. And then if we do any editing, like the retopology, I did all mine in ZBrush, so that's usually FBX format. And then when we add rig, there's another format of the rig there. So we've got a couple of formats at the bottom that are still 3D. But then as we move to the garment data, we mix 2D and 3D data. So we've got all the also types of the data, like the PBR, Collada there. But we also have just PHP there, which is one-dimensional. And as we go to the manufacturing stage, everything becomes 1D. So how do manufacture assess based on the spreadsheet if they do the good job? So we do all the good jobs on the avatar because we already can work with 3D data, but we don't have those capabilities at all right now in the manufacturing. So all the details we collect are lost at the end because the format is just the spreadsheets.
Yeah, we haven't even mentioned all the CAM formats. We thought we'd leave that off for clarity of detail. So I think the next one is, how do we implement this? So we're going to go back to the either the file format one or the one before that. So this is just
this one.
Yeah, this is just the reality of what we're dealing with. So if there's any thoughts on how we get like how about two? Okay, so and I know there's also some questions online. I saw something on that. I don't know who's been monitoring the chat, but so we'd like any discussion on that or the online questions. We'll be glad to take those now.
Okay, amazing. Yeah, this really helps to sort of see the scope of the challenge you guys are facing here. The question online is from Lewis. He's asking about many manufacturers using something called Marvelous Designer.
Yes, that's a baby thing of Clo. That's actually related to Clo.
That's for the gaming. That's the problem. Marvelous is for games design.
Yes.
It's
and
the Clo it's for the apparel, but because the skill level in the Clo or some like browserware, which is also much more hefty in price,
one's got
is
more
much more difficult
generation than the other. Anyway, sorry.
Okay, so I guess so. You're right. Maybe he's mentioning that. So the origin or use of this tool generally is in a digital twin metaverse thing. So the humanoid of somehow. But so yeah, I guess the question is, if you summarize, kind of compare and contrast about where that lives with your work.
So basically, Marvelous Designer is a good tool to design. But that doesn't mean designing is not pattern making. So it's really key to understand that I can draw a really great dress, shirt, jeans, whatever, but now I have to make a pattern. And I have to take that 3D body. I then have to derive the 2D body that actually works for the pattern making, because the pattern making is actually dealing with 2D materials. So if if I have a material basically or fabric, it's 2D. It's actually, if you're going to model that 3D wise or in a 3D package, it's actually a 2D membrane object that you then assemble such that you are now making not really a shell, it's actually a membrane, and it's actually a 2D membrane object that occupies a 3D space, which is how you have to think of it that way. So I would say that Marvelous Designer is great for designing. I would then bring it into Clo, which would then actually do the patterns, which would then actually, you then have to assemble that around the body, but you're assembling it on their rig and their traditional, especially for women, hourglass bodies, which may or may not, and probably the word is not, be the actual customer that's buying the product.
But Marvelous is also for gaming, so we have to distinguish between different kind of audiences. So there is different level of expectation for the level of detail, and what Marvelous will do will be great to put the character in the game, but it will not be useful for this process really.
Interesting. Yeah. So that sort of talks or maybe indicates a little bit about the direction of flows that you guys identified early on, which I thought was really useful. Yeah. Any other questions? Yes, we do have some here.
Oh, good. I paid her off really well.
She's lying. She never paid anything. It is really impressive work, but I have a very down-to-earth question. I know it's not for right now, but how long do you estimate the time between me going to the shop, doing my fitting, and me receiving my clothes? Imagining I live in the US. And what happens if, I don't know, if it's too long and I took on 3 kilograms or something doesn't, I don't like it that much. What can I do? And third down-to-earth question, compared to just going to my regular store and buying a jean and t-shirt, how much more would I pay for this very interesting, very fitted clothes?
So the
process.
Right. So at first it was like everything needs to be mass customized. And the reality is, if you're going to wash your car, you don't care what your t-shirt, how well it fits, right? So there's two different markets. One is I actually want to get a suit jacket or something. I actually want to look good, if you know what I mean, at a next level. I would definitely want to go this route, right? Because then, and I would say it's generally, I think 3 weeks is kind of in the US is what they're getting, because they do on the back end, they actually go through and somebody's still with a paper and adjusting and making that pattern. But there are kind of providers online. You also have outlier bodies, which are a larger percentage of the population, right? If I'm perceived as too tall, I'm perceived as too short, I'm perceived as the ratios isn't correct. They've found, I know other brands have done it when they've done morphotypes, that there's 16% of the population that we don't really design clothing for. And it's because they might be a pair with a little extra on the top. I mean, and we just don't think that we want our clothing, and you actually get this in footwear as well. I don't really want my shoes to be on your feet because your feet are ugly. I'm like, don't I get to wear shoes? I mean, I know that's kind of a requirement, especially in the winter, but their view is that's always somebody else's problem. And so there is a whole group that I think, needs this. And so do I see you doing that all the time? Depends on your body, really. I mean, you may be in that lucky area where you go, this is close enough. And that was our description of fit. It's close enough. It's not the ideal fit, but it's close enough. It's an optimum fit for what I'm doing. And I'm willing to live with the fact that it's a little short in the back, right? It's not something I'm going to go wear to the Oscars, but for 3D, for this conference, it works. So you kind of have a range of clothing. And like I said, then you have the outlier bodies. And people are definitely realizing outlier bodies. Like if you have Down syndrome or, whatever, right? I mean, it's like I said, it's 16% of the population that they just have to wear a tent and hope it looks okay. So,
but it's also the scalability factor here. So if you can actually scale this kind of model really well, you don't know about all those aspects because all of this happens in the background. So you actually eliminate this whole shipping and traveling to let's say, China, Bangladesh, India, and not knowing really what happened with your clothing or where it was. But it's local, so it will be produced close to you. So it actually may not take that much time. It's just figuring how all those aspects will speak together. But once you've done it, it will not be different than the traditional e-commerce.
Okay, yeah. Thank you very much.
Yeah, I mean, the volume that just gets straight to the landfill is absolutely amazing. I mean, it's almost a third or something like that. I mean, it's absolutely amazing. And if you could skip all that energy usage, right? I mean, one of the things I looked at one time, I'm like, the amount that we throw away is the amount that, because they have a custom jean factory in LA right now, and the amount that you throw away, you would have to provide 5 or 6 more factories just to produce the stuff you throw away. We haven't even talked about what you actually use, but so it's the amount of waste that's in the system that's not apparent until you go to one of those like big department stores and you're like, there's a lot of clothing here and I don't really like any of it, right? So if you actually say that out loud and all of that gets thrown out, it's quite a bit, so
there is like a really nice paper even in the Nature, which is a leading scientific journal, that actually quantifies some of the impacts and the footprints of the fashion. So could be useful to reference.
Yes.
Thank you, Nicolas. Great presentation. So I know that you also come from a different conference that took place
in Lugano, yeah.
Yes, so this 3D Body Tech conference. I was just checking the webpage, and one of the things that I see there that is pretty obvious is that there are several companies trying to actually scan the body in order to construct these apparels or for other things, right? So I want really to understand if what you propose here is a kind of common flow that all these companies could look at based on the standards or something like that. So that if even new companies come into this game, they should follow this kind of guidelines. Is this the message?
Yes. So and right now they're trying, but the 3D scanning, they're like, why hasn't this been universally adopted? It hasn't been universally adopted because apparel can't absorb the information you're giving it, right? I mean, it's like it's too big of a, it's like kind of a pig and a python, right? The pig's a little too big for the python to eat at this point. So the goal is to try to be able to say, yes, here's the standard. So we don't care how you get to the rig in terms of what algorithms you're going to be, but you need to be able to provide the rig that meets the needs for apparel. Right. So that's the request. I mean, you may put your pants waist, for example, is all over the place in terms of if you're a guy, you tend to wear it underneath your little belly. And if you're a woman, you'll wear it wherever you feel like it. And so that's a pants waist. Well, once I just give you the waist of the body, then you can do your design based off of whatever you want. Right. So we're trying to get the scanning information to be in a situation that apparel can absorb that information. Because right now we're actually doing a study on the side where we took 4 different phone apps and we said, can we get the same data and I took the data and I said, okay, if I take it at this height, do I get the same data? And the answer is no. So you actually, which is why when you're on a phone app, if somebody's providing something, they may go use this phone app. Why are they telling you that? Because they know the data output such that they know how to handle it. So when they go into their pattern making, they know how it relates to their pattern making. So pattern making actually hasn't caught up with 3D information. And so that's one of the things that we're trying to address as well, is how you deal with pattern making such that it can handle 3D data. Because right now it doesn't.
Okay, so that was one of the questions, because I see here, like, I don't know, 20 companies or something that went to your conference, right?
But it is also worth mentioning that this is not something that one company can handle. So we would really love to do the experiment to go through all the stages, but this is not just one body scanning company. And right now, everyone coming from the mindset that there is just one company and we can solve the whole fashion problem because fashion is trivial. We don't should spend too much time why nobody done it before us. And I work for one of the company that is actually trying to figure out some of the elements, but we really struggle to find the partners that can handle other parts so we can do the whole customization together. It's not one man, it's not one company that's gonna win this game. It has to, this is why we put the file formats, because they need to speak to each other and they need to collaborate and have the same common goal.
Yes, and the other question is, this is obviously comes from the individual body to the 3D model that could be used in the metaverse or could be used for garment design or whatever. And there is a lot of research in the other way, which is also the digital garment design. So how can I realistically simulate the clothes, the motion, movement, and fitting, and so on? So I suppose that you are also bridging with this community, because there are very interesting things happening there. So I know, for instance, in Spain, there is a very strong computer graphics group that created a company called SEDDI, S-E-D-D-I, that is really, I think, doing an excellent job in simulating how, the clothes really fit to your body, okay? Of course, they don't specialize in scanning the body. They took the body as granted, so to say. So if you match interests.
Yes, and that's kind of and that's what's really needed is, we have to be able to match it, and we have to go through the entire workflow, and just what does that workflow really truly include? And so that's kind of what we wanted to show, was just like, it's not just one part, it's not just the other, but it's all three that take it to work together.
And then there are also interfaces that we have to design so the customer can review the product.
Right. I mean, you've got, I want to be able to see. And I mean, one of the good things that did come out of COVID was that you couldn't just fly to a place and see how it was made, right? I mean, COVID really showed and really accelerated the 3D design aspect in apparel, because suddenly all of those samples that you would get, you went, I can't do that. So now I have to test visually, and now I can pick, that purple just really is bad. So I really only need a sample in the red now, right? Because I have a visual confirmation and I get less samples. And so the sampling has actually gone way down because of the 3D as well, just to let you know that there is some kind of within the ecosystem, there is recycling within the ecosystem, but there's not a whole lot of post-consumer. So it's how to decrease the post-consumer aspects of it at this point. Any other questions that people have seen online? Because I can't see the chat. Oh, Anita, yes, you've got a question.
Yeah, I can probably do this.
Yeah, we can probably get.
I don't know if you're going to be discussing file formats in your next presentation, but again, we've talked about this, about how do we convince these scanner companies and all these other software companies that are exporting everything to OBJ, and that's what, it's not even a supported standard. It's just been around for years and years. How do we change that man's mindset, and what can we do as a standards organization and as users here to convince these people that maybe it's time to move to file formats that provide you more information?
I mean, the same
you
thing
talked about metadata,
Yes, just wanted to say the same thing was with Amazon. So until they haven't done it, no one did it. But once they were successful, a lot of people migrated. So we need one or two companies that will succeed and will show that this kind of framework works. And then a lot of other players will be like, oh, we want to be a part of that because this works and it's exciting. So we just have to show that it works.
And I think we also have to make it easier for them. These people aren't tech people. It's kind of like driving a car, right? Not many people drove the car when you had to do this, to crank it up, to turn it. But once you got power steering, people drove cars. Do people know all the mechanics behind the cars? The answer is no, but they know how to drive. So I think, quite truthfully, well, you can just add a node and an extension. You have just turned them off. I don't want to add a node or extension. I want you to go, here's my avatar, put that baby, I save it in here. The rig's already there. It's the apparel rig. I'm done. I just dump it on in to Clo, to Browseware, to whatever, and I'm done. I don't have to think about that, which is you've really got to make it simple, because they don't want to get under the hood. at all. They want that little package. They want it to come in. They want it to be able to work, because what are they doing? They're designing clothing such that the essence of the clothing is that you want it, right? They're going for your heart. So they don't want to focus on the other side of it, right? So our job is to do the how, because they're going to do the what. And I think you really have to understand that I'm going to make the how as easy as possible so you can do the what, because that is their skill set. I mean, I wouldn't necessarily know that, oh, I should have a black, trim here, and that makes my jacket look better. I'm an engineer. I don't really care, but they do the what, right? And you appeal to that, and you need to make it really easy for them to do the how. And I think that if we can come out as a group such that the how is easy, let them do their skill set. That is their skill set, and really honor the fact that that's their skill set.
Any other thoughts? One thing that occurred to me, it's rather mundane, maybe, but it's a little more on the graphic side, is when you're talking about the first loop and geometry, topology, and these sorts of things. Is this, do you know about the things about the mechanics, like, for example, is it triangles or is it quads? Because I saw two different figures about your mesh.
Yes,
meshes
so
that you
basically, when the body scan comes, they usually poly triangles. But if we want to do the rig, like in graphic computer, what I would do, I would go to the quads in during the retopology, because this follows the bones and muscles. But as I change, I also have to take this kind of fine details, because my avatar will lose the details. So I have to kind of do a few tweaks. But I only suggested this here as an example to show how the industry works now, but maybe we can figure out the way with the triangles, so then we don't lose these details, but this is how it's commonly done right now with the quads.
Okay, great. So that's sort of that's the kind of requirement we can hear, and it makes immediate sense about representation and digital graphics, and why certain formats might be more appropriate for certain kinds of representation. So that's really great. Thank you for that answer. The other thing was, it occurs to me that although there's a lot of, you did mention PLM, and this whole idea of digital twin in manufacturing is quite mature in other industries, let's say, or it's reasonably mature. As insofar as there's a software price, but you're getting lots of business value out of this. The other things were a little more difficult, right? You had lists about all of this knowledge that is somehow implicit in your industry. So the drape, the fit, there was lists of
heuristic. It's in the fingertips.
Right. Well, this sounds like a knowledge modeling opportunity, right? So you're doing multiple attributes, you have relations between these and different kinds of constraints. And so maybe even more than just sort of what we might have like a spreadsheet or a schema, there are ways that you could undertake maybe to build something like an ontology, right, for this particular domain. And that could help sort of find gaps, maybe find new opportunities between some of these concepts. That's still a bit of an opportunity, maybe open, and we do definitely have some experts in that area in this community. So.
Yes, I think that would be great, because the ontology for like how to model all those things is very much missing, because the fashion industry itself is very descriptive, but we also have some testing done for the real fabric. So now is the question how we can get this data from the real fabric, and how can we model this for the ontology for the digital fabric. So this is something that could be easily translated if we get interest from the engineering community to help us out here.
Yeah, excellent. Thank you. This really learned a lot here. So thank Thank you for your presentation. You have another section, or what's the schedule?
No,
here?
actually, we were
No.
gonna do the
Okay.
old thank you and
All
feel
right.
free and the usual contacts. We're at 14:46, so we actually left enough time for a little bio break for those of you who want to do that before the next session as well. So
Yes, and if you have any, like, if your company or you work in any of those components that you think maybe you solved to a certain extent, then don't hesitate to contact us. We would be really, really keen to, as I said, do some more experiments to show this in the practice.
Okay, thank you very much. Yeah. Let's have 10 minutes of installation break. Make sure that everything is going smoothly for the next session. And we will be back at 3 local time. Yeah, I would. Yeah, Alban, yeah. Yeah, actually, this is what I want to do, test with Alban, that he has the audio. Alban, can you hear me? Not yet. Is connected, Alban? Yeah.
Allô, allô, vous m'entendez?
Yes, we can hear you, but we cannot
Marius.
see your camera. Okay,
can you see me now?
Yes, great.
Can you hear me?
Yeah.
Bon, désolé Marius.
Right. So Alban, if you want to see the list and the order, you should go on the conference webpage. You have it?
Yeah, I have it.
Okay.
I have it in front of my eyes, so everything is fine.
Great.
So I have the 9 papers, and with the multi-author, I don't know who will be the presenter, but I suppose that Jorge will be the first one.
Yeah.
So-
No, it's not. It's not Jorge. For the first one will be Bruno.
Okay.
Yeah.
So I will call for the paper in the order of the list which is on the website, right?
Great. Yeah.
That's perfect.
Good.
Thanks, Marius, and sorry for the setup issues.
No problem. We'll start in 10 minutes. Okay.
Yeah, I'm fine. I will be here.
Great.
Thanks. I think it's time to start, right? Is everyone in the room? Not sure.
Yeah, we are half of the room, but just wait two more seconds for people
No
come
problem.
from the coffee break. Yeah.
No problem.
Okay, so yeah, let's start our last session. Not the less important, maybe one of the most important, because this is about industrial use cases. So this is how all the technology is used and useful in real life. So we will have 9 presentations, and we have Alban Schmutz, who is also a representative from industry, that will help us, and he will chair the session. So Alban, yours.
So, thank you, Marius, and hello everyone again. So welcome to this industrial use case presentation session. I think this is something very important. As some of you know, I'm coming from the industry, and this is very, very important to me. First, I wanted to apologize since I was with you in person for the last 2.5 days, but due to an unexpected last-minute personal issue, I had to move a couple of so 1.5 hours ago. So I'm in distance now, but I hope this will be still a great session. The second thing I wanted to mention is that today we are celebrating the 10th anniversary of these industrial use case sessions within the Web3D conference. So I think this is a great milestone. And if we look back of what happened in the last 10 years in the industry, so we had the discussion with Johannes during the lunch, I think this is something very, very impressive. So I don't know where we will be in the next 10 years, but if we just look back, we see the importance of this topic for the industry and where the industry is now today. And one of the things we see emerging, we have been discussing this also I would say inside talks the past 2.5 days, is that the question of regulation is coming alongside with the development of technology today, and we are not under the radar anymore. And so the regulators enters into the game, where we used to be only, I would say, between techies to define what are the right standards to move forward. So I think this is one of the main things that's going to happen in like 10 years. And the third thing I wanted to say before we start the session is that here we have a block of 2 sessions. First, we have this session of 90 minutes where we're going to have 9 presentations of 10 minutes each. So my role here will be to be the timekeeper. So 10 minutes sharp to be on time. There will be no question during that session, but the second session, which will last 60 minutes, will be the I would say the poster discussion. So there will be plenty of times to have the discussion in the session after. So, and I recall also everyone to stay with us since at 5:30 we're gonna have the awards. So it's also a very important moment. So I stop here. Thank you all. And first I give the hand to a paper named Digital Twin and 3D Web-Based Use Cases in Industry by Bruno, Maria, Jairo, Carlos, and Jorge. I hope I spelled all these names well. Thank you so much.
Thank you very much. Can you? Okay. So if I understood correctly, it's 10 minutes. Okay.
Yes.
Thank you very much for letting me present this work. This is a work collaboration with a lot of partners, a lot of industry, and as well a lot of people here. We all share the same credits, although I am. So the order on the list is not very important. I attended so many presentations this week. You all guys did so many amazing things that sometimes I think what I'm going to present here is not new, but there is something that we share. I just realized we share the same problems, so they must be real. Okay. So first, just a quick presentation. We are a foundation, we are not a university, and we are not a company that works. So we try to bridge research with applications in the industries. So we try to do that bridge and convert this research that sometimes is purely theoretical into real applications. Our main expertise are these two domains, visual computing and interaction, and as well as intelligence, artificial intelligence, that nowadays is playing a bigger role. So our size is more or less this. These numbers are probably not very accurate right now, but this is more or less who we are in terms of numbers. And for this presentation, I will just give a brief description of what a digital twin is. We have talked a lot here about metaverse. I'm not sure if this is metaverse. Maybe we need to wait for a better definition in order to understand how this relates to that concept. But after the definition, based on the work we did, we will present some microservices and how we could design digital twins in a quicker way and without requiring so many technical skills. We will finish with like some future directions and some lessons learned. So here, by digital twin, we just mean digital representation that can represent unique objects by objects, for example, robots, as well as processes, activities that these objects actually perform, as well the entire environment itself. It's important to keep in mind that this is just not a virtual representation, but there is also a connection with the real world. So not only it reflects what the real world is, but it also enables users to interact with the real world through these virtual spaces. Some of the capabilities that we have here, or that we many times want to have here in a digital twin, is the possibility to monitor the physical spaces as well as to perform simulations, so we can optimize without actually performing these physical operations that sometimes require disruption of the factories. But the most important is that we can plug the physical components with software, and nowadays a lot of AIs enabling new things like prediction, maintenance, as well as weather recommendations for optimizing the layouts. So this is a very large topic. These are some of the capabilities that we may think of a digital twin. It covers a lot of topics, from interaction to data to as well as processing and interfaces. We will focus on a few. So this is what we wanted to cover more or less here. So we are aiming at realistic rendering as well as physics simulation with some AI. So we can enable certain processes like a digital design as well as training and monitoring. So our use cases will focus on three main topics. The first one is how to connect, not only to machines, but also to users. And the biggest one is on the visualization. I think it's the most relevant here, and it's the one I would like to explore a bit better. But then related still with the visualization, because we are going to present a tool where we could design or potentially design a digital twin just by performing some drag and drops without no programming involved. We also present some concepts on the microservice. So connecting a digital twin to the real world can be very complex. There are a lot of different systems that we may have to connect and get data from. Some have standards, others are not so standardized. But what is constant is actually the amount of data that we get in real time and the frequencies. But on top of this data that most of the times is generated by a machine, we have another important component that is the human machine interaction, which also plays a very important role in all this process. In the next use case that I will present, we will focus a bit on this concept. So our two projects with the companies in the Basque in country. Both companies are very large in terms of workers, and they employ people with disabilities. So they try to enable, give a better life to these people while make their life also a contribution to the society. The problem is these people have a lot of different disabilities, and this is not very well covered. So for example, some people cannot read. So if you provide instructions that are textual, they cannot actually take them, but some other people cannot see certain colors, cognitive disabilities of other orders. So here what we were trying to explore was a tool that could enable overlay content on the shop floor that was designed and personalized for different type of workers. So this was our first approach to trying to integrate in the industry the web. Later on, I can present a bit more of this. This was using projected augmented reality, so we could overlay directly on the faces different content. Another, and this is where I would like to spend more time, I don't have probably much time, is related with the visualization. Well, visualization in industry has a lot of issues because mainly some of the CAD models are very large and they change quite often during the design phase, that trying to build a pipeline where you could actually experience in virtual reality a CAD model that has like photorealistic materials can be very challenging. First, because of the limitations of virtual reality, but then all the process of optimizing the models to virtual reality. So in a first approach, because our models could only render on specific machines, we followed the following pipeline. So we would import step files around 6 gigabytes, and on a specific machine with the Unreal Engine, we were rendering and streaming the interaction through WebRTC to a mobile, so the users could interact on the mobile or a desktop application and be able to explore photorealistic models in devices with lower capabilities. The problem here is sometimes the tools are the problem that we have. And if people you work with are used to tools like Unreal for this kind of editing, then if you want to work with other technologies, you are a bit limited to that. So there was another problem here that was traceability. So if you import a model in Unreal, then you perform CAD changes to the model, then you need to understand what changes were done in order to not lose the second step of the modeling. So for that, we created a tool in the previous project, since it was a limitation, that would enable converting and optimizing quickly models to web standards, or at least formats like X3D and GLTF. And this was one of the first projects already fully using web technology. It was oriented to formation, so we could describe how machines work and interact. So for training purposes, in this case with 3JS and GLTF.
1 minute left.
Then, well, this was presented last year. It was, well, last time in the Web3D. This is a export from the tool that we created in the previous project, where we export a 3D scene with behaviors, cinematics, and animations. So we can just open the browser and explore and interact with this type of 3D models. There was a limitation here, which is the limitation that we are now addressing in a different project. That is how we could easily connect these representations to more complex operations. For example, if we want to create an application for giving information, so the user needs to turn on some machine, then do another step, how we could validate that kind of workflow without having to program this kind of tools. So later on outside.
This is the end of the presentation now. So I'm sorry I have to interrupt you. I can give you 20 more seconds if you want to finalize a sentence, but this is the end of the presentation.
Right. Okay, so then that will actually enable us to use simulation and other services.
So thank you very much for the presentation. Sorry for being sharp on that, since you have other friends coming for the next 8 sessions. So thanks a lot, and a big hand to you. So now next, we're gonna have a presentation named Industrial Use Case Digital Twin for Autonomous Earthwork in Virtual Reality. Prepared by Nicolas, Léa, Samuel, Oumayma, Jean-Charles, Marius, and Catalina and Titus. I hope I didn't forget anyone.
The order then Alban is using is the one from detailed program. So if you just look at the printed version, is not the right one. Go on the web and check on the detailed program. That is what Alban is using. You confirm, Alban?
I'm the one. I'm on the web here.
Okay, good, great.
All right. Hi. Hello, everybody, and thank you for attending. So my name is Nicolas Hoffmann, and I have 10 minutes to introduce you to our work, Digital Twin for Autonomous Earthwork in virtual reality. This was a highly collaborative work, and I'm very thankful for all my colleagues who participated. So first, I will introduce a little bit of context about the company. So this is Heracles Robotics is a company whose aim is to develop autonomous earthworks. So you can see here an example, not very HD, but you can find the video on YouTube. And this is basically a big machine digging some dirt, and there is no driver inside, and there is no one with a remote controller. It's entirely autonomous. Everything is computed on board. So this use case actually begs the question for the interface, because we want our users to use the system, and our users are non-roboticists, non-computer scientists, land surveyors, and they are autonomous workers, and they don't know how to use the tools that we specify. So one of the constraints our interface should have is to provide to the supervisor an understanding of the scene, to know what has been done before and what needs to be done, to instruct the machine, to tell them what to do, where to go, what action to perform, to unstuck the machines when there is a big rock in the ground and they have to stop. And everything needs to operate in real time. So we have the perfect solution for that as roboticists. And this is a CLI, a command line interface. And some of you may recognize the use of ROS, a robotic middleware, but you have a lot of data spit at you all the time. And of course, non-roboticists, non-computer scientists cannot use this tool. So this got rejected by our users. Yeah. And so not only do we need to develop an autonomous earthwork system, but also the interface that goes with it. So a few words, I mean, most of my words on the system that we developed. So yeah, it looks like this. You have the image in the middle. Okay, so on the left, you can see the real scene. So the real machine doing some real work. And on the right, you have a VR digital twin of the same scene. So this is the real data that we gathered. You can see some nice little toys here as well. And this is still work in progress with many colleagues. And this, at the bottom, you have an illustration of how it works. So basically, you have the supervisors who put the helmet and sends commands to the machine. The machine is connected to the same VPN or some networks. And it sends the commands, either low-level commands or higher-level commands that we will discuss a bit later. The machine operates in the scene, modifies the environment, follows instructions, and sends back to the supervisor the proprioception, so the position and all the angles of the joints, as well as an updated map of the surrounding. The map changes a lot because we dig into it and we put the ground elsewhere. So we need to update it. For that, we equip the machine with the LiDAR sensors. And by mapping everything over time, we can construct a dynamic 2.5D, a height map of the environment. And by sending this into a VR system, we can get a scene we can evolve into. When we have this scene, we can define some actions the user can take. So everything starts with the controllers. We defined, kind of hard-coded some different sets of actions, some low-level actions, some high-level actions. I will talk about it next slide. And once information is provided to the robot middleware, we can translate this into low-level instruction for the robot, and the robot does what we want. I talked about the actions. So first we have the low-level actions, which is when the controllers mimic the joysticks. I don't know if many of you have been in such machines, but it's very simple. Each articulation has one degree of freedom, and basically the controllers are just like that. But also we plugged it into our high-level action systems. So here you have an example at the top. This is a pick and drop macro actions. So we specify 2 positions at the top to the machines. And from A to B, first the machine goes where it needs to go. Then it operates a loading procedures. Then it goes to an unloading stage and operates an unloading procedure. So we need to provide 2 positions, 2 geo-referenced positions to the machine. And this is done using geometric primitives. So this is what you can see around here. So this is a bird's eye view of the scene. And the level of gray indicates the altitude known by the robot. And this is actually what a real robot sees in these operations. And you can see 3 small robots. You have Spoony here, a small excavator. You have a Spanderful, which is a bit bigger, and T-Rex for the tracks. And we highlighted 3 kind of primitives here. First, we have the points, P01. It's just one georeference coordinate. We can provide an angle with it to make an arrow or a 2D pose. This is A01 or A02. And you can set a list of points to define a zone. This is Z01 at the bottom. And once we have this, we can specify, we can ask, for example, T-Rex to operate this operation between A02 and A01. When it comes to our current results, so this is what it looks like. So this is the real scene that we gathered from a real site. For now, it's not in real time. So we can see the machine evolving in the scene, and which is this is a model of a real machine operating in the scene. And so now, for now, we have a digital twin of one single machine simulated in a VR system. The real-time technology lock was lifted recently, so we are actively working on synchronizing in real time with the real system. For now, it's not the case, but it's well in the process. And we also have the dynamic height mapping of the environment in real time. So the information exists, but not in the system for now. Just few words as a conclusion to be fast about it. So a lot of perspectives. First of all, we want to link it to the actual machines, of course. Also to develop different tools for the user interface. For example, integrate some eye tracking technology to track what's happening, what does the people care most about. Also monitor the stress and motion sickness with a brain interface. Develop even more the macro actions from the geometric primitive, as I mentioned before, or some intermediary controls, because we strongly believe that it could provide a lot of value. For example, it's very difficult for an operator to move in a straight line with a machine because you control the angles. So you do a set of arcs, and it's very difficult to do a flat surface, for example. So we could set, okay, I set this plane, and you can only operate in this plane, and this could provide a lot of value for the different operators. Also, we are working towards making the system cross-machine. So we have bulldozers, truck loaders, excavators of different size, different shapes, different number of articulations. Also working towards supervising an entire site instead of just one machine. So the goal is for the land surveyor to operate a fleet of machines, so they could walk around in VR. point at the machine, click on it, and take control of it, for example, or to see what the machine did before, what is in its intent and stuff like that. And finally, designing operator training programs so they can train a new machine or a new kind of machine before setting their hands on the actual 20-ton machine. So yeah, I would like to reassess that this is a highly collaborative work, and I would like to have a special thank for Léa, Saunier, Samuel, Prouten, and Oumayma Serroukh.
Thank you very much for this interesting presentation and to be on time. So thanks again. I know that it is a difficult exercise to be to summarize things. So thank you a lot. Now we move to the next paper. So the next presentation being 3D connectivity for digital twins by Christian and Johannes. As usual, setting up takes a couple of minutes.
Nicolas, you still share your screen. That is maybe the reason.
I tried to share, but it doesn't.
No, was Nicolas one. Oh, that Nicolas, which is near you.
Yes. So, was it? No. I did it. Yeah, okay. Yeah. Thanks.
So go ahead, Johannes.
My name is Johannes Beer. I'm the second author from this contribution, and I'm going to talk about connectivity, 3D connectivity for digital twins. So we are now part of the company 3D, which we founded 2 years ago, but the whole team that developed software and transferred was at the Fraunhofer IGT in Darmstadt for a couple of years. And even though the company is pretty young, so it's only 2 years old, we have now 40 people that work on this instance 3D hub architecture, which is this visual computing architecture for industrial 3D application, mainly in the field of digital twins. And I will talk about this a little bit. The interesting part is that we have an interesting list of customers that have really rather large and complex data sets that needs to be managed and accelerated for their interactive application. So what is the core idea of this instance 3D hub platform? So that's not the first visualization, not first visual compute architecture that we have built, but that's the target is really different. So before, with the X-Freedom system and also with the instant reality system, that it was always for visual computing experts. So you have to understand, okay, what's a triangle, what's a file format, how to deal with document limitations. So it was always about compute and data sensitivity. And that's something we really try to get rid of in total. So it's really the first data-driven end-to-end automation system. So we measure all the time different values for the infrastructure, but also the end user quality and the responsibility and everything, and try to optimize this all the time going on. So that's the core difference. So not a computer science expert tries to deal with different data sizes, but that the system really does it. And the really neat thing about the approach is that the audience is really different. So it's not computer graphic experts that build the application anymore, but the domain experts. So the people that build cars or buildings or others can now deal with the system. And we think that's really unique to our domain, because it really looks like that building a successful pilot or POC is really simple. So people use game engines or some other really simple and neat technology, build the first augmented reality or other application, and then they try to scale this, which means you get in data sizes, but security, distribution, processing. And a nice example is we showed this demo, which was with BMW at that time. So it's almost 25 years ago at the CeBIT fair in Darmstadt, in Hanover at that time. And after the fair, it was clear. I mean, in the background was a huge SGI machine, and it was we spent almost a year in a project to get to this result. But it was clear that augmented reality in the service field is something everybody wants and needs. And today, even though there are a lot of companies, it's still too expensive. So they have pipelines that needs to be managed different, and so it's not there yet. Okay, so that needs to change. What we really try to do is something that is really visual computing as a service infrastructure that can address data in different backends. So in your PLM, PDM system, but also in your digital twin and IoT structure. For example, is something we do with Microsoft. There, we export their digital twin structure in our spatial struct in the system. Then we build APIs or have APIs so you can address all the data, original depth, original data fidelity. That's really important. So it's not reduced data, but it's the original data. And then on this whole construct, we can really do and guarantee this scalability promises to run any data construct with any device and any size. And that's just a couple of applications. So people really come build the digital twin along the full product life cycle from construction, design reviews down to service application. And on the other hand, really would like to use all this different compute and application pattern. And the problem is that this should all work even if you have a HoloLens and 15 gigabyte car configuration, which I just show here again. So this is the slight idea that if you try to minimize this, is really something like having Google Maps for 3D data. So this is fetched live data from a PLM backend, where it's about 15 gigabyte of cut data that gets then optimized spatial caches, organized and sorted on the server. And then this visualization is all done in the web with just streaming fragments of information, and the fragment information of the visibility information for the correct is used to fill the pixel. And the nice thing is that all the depth of the data, all the fidelity, so all the cut information, is still there. So you can do measurement, you can do clash detection, you can do everything on your data without losing anything. And this is something that's really unique and leads to this rather simple but really powerful overall construct, which is this visual computing middleware, where people just have two levels of APIs. One is where they plug in their data sources, and it's a very simple, we only have to implement two functions to get a valid data. So it's about security and data negotiation. And then on this data layer, we transfer discrete states of data into the 3D system. And then from here, we do all controlled streaming to the different clients and then manage security from the actual user down to the data, which makes this extremely interesting for collaborative scenarios. So this is the system that we built. The interesting part is really how we address data. How can we be format agnostic, but can still be able to go through all these hierarchies and spatial structures, and that you can have APIs on your spatial structure, can do a spatial search, can say, okay, I do a selection in my space, and all the data that there, I do operation on this. And that's something really unique. Most others, you have to convert to a specific file format to get something like USD is something like this. In Omniverse, you have to convert everything to USD, and here you can keep it. So this is something interesting also on the API level, because you can do spatial queries and database queries in combination. So that's something really unique. And that gets me to a couple of customer examples that I just would like to show. One of two or three larger ones. So two are building cars and second service case. So BMW is a customer that we already have for 6-7 years. They were really looking for some technology to build, bring CAD data to the web first, and then but now they have really built, it's between 15 and 20 different use cases. And there it's all about collaborative platforms. So getting engineers and people that provide the data from external, so supplier portals and everything that's integrated in their system. And the neat thing is that they really can do all this on their live data, so there's no preparation or anything. They just fetch, they use their original part IDs, and we just build these caches and everything on the fly. So that's
40 seconds left.
Sorry?
40 seconds left.
Okay. So other part is Daimler. Daimler is a little bit different. They have also a lot of augmented reality. Siemens is another partner that we have. They do use it for machinery service and after sales service. And that's it. Get me to the last one. So
thanks, Johannes. So sorry for being sharp again. So please, next one we can start to install yourself. And just maybe, since we cannot have questions, but maybe for you, Johannes, maybe we should discuss later on how you gonna get your service labeled within Gaia X with one of the 3 levels of labels of Gaia X, where you are, since you are working with Catena X. I think it's a discussion we can have. For those who don't know, Gaia X is the largest European cloud project with more than 300, I would say, industrial members, which will have its annual summit in this, I would say, in 10 days in Paris. So next on stage, AR for manual assembly industry, Emmanuel Tryon.
All right, hello everyone here in the room and online. So I'm sharing the screen.
Let's go.
Okay. So I'm Emmanuel Bricard, a former Chief Information Officer from Bosch Thermotechnology in France. We worked on this project with a lot of great people that are in the room. Ryan Lavric, Hugo Durchon, Abaya Arriguet, and Marius Preda. So thanks a lot. We discussed about augmented reality for manual assembly in the industry, and I tried to show you some concrete examples of the difference between working in the lab and working in a production plant. So what is the project context? Why we did that? The idea is that today we live in a world that is more and more, the VUCA world, volatile, uncertain, complex, ambiguous. The world is completely crazy. Things happen that are unpredictable. And all this have an impact on production areas, on factories. All this breaks the supply chain. And if a production plant do not have the parts to build products, they cannot work anymore. So the challenge now to face this situation, because things like that keeps happening and will happening again, and probably even more things. So the challenge for industry is to be able to develop their own flexibility. And what flexibility means? It means you have the capacity to do something else of what you planned. Do something else with your machines and do something else with people. Here, with this project, of course, we'll focus on people and how to help people to do something else fast, in a reliable way, with augmented reality. Two focuses, two objectives: be able to train operators from the shop floor at their workstation. So at a workstation they do not know, for them to be able to work. And another thing that is very important, create the instruction they will use to learn. Instruction, if they are not up to date, are useless, right? And the problem in the industry, to create an instruction, if you need an engineer, is never available when you need him. It just does not work. That's just the true life. If you need the IT guy or the method engineer, it just not works. Which means your training system that is great and that is very technologically evolved is useless, simply as that. So the challenge we decide to face, is to have an authoring tool that allows the guy from the shop floor, the guy from the field of the factory, to be able to create themselves the instructions without IT guys and engineers. So literature tells us that augmented reality is supposed to provide better training, reduce training times, reduce mental workload, and reduce error rate. So it's wonderful, magic, than traditional displays and traditional papers, right? Okay, so let's see how the true life compares to what you have in laboratories. So you see how nice this is, like everything is really millimetered at the right place, right? This is, of course, not the real life, this is a laboratory. Here you have a lot of different components in these workstations, so many cables, so many small things that are perfectly set up at the right place. Here, you take this, you put it here. I don't know how many hours it will work because it will be destroyed. I mean, literally destroyed. So it will be broken by people because this is not a war zone, but close in some aspects. It's unfriendly. It's a mess. It's complicated. It changes all the time. You have this part that is not available. You have this part at the place of the other one and so on. And people not trained come here and maybe are not that engaged in their work and break things. So this is the real life of the industry. So how, in this context that is kind of crazy, under pressure, because if you have your supply chain that is broken, you don't have time to think a lot, right? You have time to try to save things, or at least the one you can, and the one you identified as problems. So how augmented reality can be used in this context to be able to work and be useful to train people in this complex environment I described just before. So the case study we worked on, it's 3 years, a 3 years project, 3.5 years even. We had 30 shop floor experts, so no IT guy, no engineers and so on. 7 departments, so all the teams of production plants. The objective was to use an AR training tool that is adapted for this, the shop floor, and not the lab and not the engineers. And the ambition was to have something that can be used without technical expertise. Because a guy who is able to build a boiler or repair a bike is not an augmented reality expert, right? So it needs to be a tool that people used as a screwdriver, or almost, that is reliable, easy to use, and so on. And what we saw is that techniques has to work, of course, because if technique does not work, nothing works. But then, of course, technique has to work, but if the organization conditions surrounding the techniques are not there, like if you take the headset, it's not charged. I mean, technique does not matter, right? If it's broken, of course, it cannot be used. And we saw also another thing that is important, functionality. You know, when you get a sales representative, it say, my thing is doing, my best software on earth is doing so many features. Okay. But if those so many features are too slow to use and slow down the efficiency of the production plant close. You lose jobs and so on. So performance is even more important than features. And beyond features, if it's not easy to use, is it not useful? It's not important that it's very efficient to use, right? So this is real life. I'm trying to give you the insider view of the industry and the life I lived 18 years that I love so much. So this is the authoring proposition. The idea is to use an authoring proposition that is able to perform in situ, so in the workstations, on the shop floor, that is immersive. With what you see is what you get, logic, that you can create instruction on the fly and change them as well on the fly, one step at a time, step by step. And again, independent from IT guys and those weird people like me, that makes things usually too complex. The idea is to use a HoloLens 2 device, so it's flexible because it does not rely on having a lot of wires everywhere and cameras that are targeting the right angles, a lot of things that needs to work together. Of course, it's hand-free because usually people in production plants need their hands to work. It's as basic as that. No desktops, complicated things because usually you don't have the space, and this is not flexible. If you need to move it, it takes a lot of time, a lot of energy, and it costs. Every second in a production plant costs.
2 minutes left.
Sorry?
2 minutes left.
Okay. So we got this. We need to have something that is so flexible. The second assumption is to use visual assets that people can create on the shop floor, which means basic things: photos, videos, text, because this is the only asset they can create. Because it's nice to have 3D animation and 3D assets, but if you don't have them on the shop floor because you need an engineering guy that is not available from the R&D department, it's useless again. And having some QR codes to be able to have a reliable and simple way to specialize things. So the first evaluation was to check the training part, was it effective to use those low-cost visual assets. And we saw that the error rate after, it was very low on the first and second trial. After the third trial, there's no errors. And the completion time increased 67% between the first and fourth circle, so it's really fast. So this was the first evaluation. The second one was to compare the low-cost assets compared to CAD models. And it's so interesting because we see that CAD models create more errors because it looks familiar. So people do not think. They think, okay, this part I need to place it like the 3D models that is there. And they stop to think and they do more errors than with photos and videos. And last thing, we evaluated the full system. So the authoring part and the training part compared to the most known of the market right now, Microsoft guides. And we saw that it's way better. The only one where guides is better is 1 error versus 2. But if you have 14 steps multiplied by 16 participants, and on every step you can do hundreds of errors, it's nothing. But we had a lower mental workload, better system usability, and 36% faster to create instructions, and almost 20% faster when you use instructions. And the IT guys, the industry guys in the room know that matters.
So time is out.
Yeah. So that's it. I hope that you enjoyed the journey in the industry. We were really grateful to have such a solution and to show that it can work in an industrial context. And of course, yeah, we have a lot of potential for future work to evaluate it at larger scale and to have some, like Hugo Deschaud is working on, some automatic process validation, and to be able even someday to create a personalized authoring and training experience. Thank you very much.
Thank you for the presentation. So please, next on stage. So Mathieu, Andreas, and Felix will, I would say, author the presentation and turn BIM in high-resolution architectural images with a web-based real-time simulation and collaboration platform. The floor is yours.
Hi, hello everybody. Yes. Okay, thank you. Perfect. Hi everybody. I will present you a BIM web platform to turn models in high resolution for architecture. So I'm present myself. My name is Mathieu Lalanne. I'm CEO of DB Lab. DB Lab is a French company based in Paris and Marseille. And we are software developer, and we develop many BIM platforms for many customers in IEC industry. We work with Vinci, we work with engineers like Europe, we work with Building Smart. We are specialized in BIM processes and about web technologies. In a previous life, I was an architect. And so this is the theme of the session today. So we develop many BIM platforms, web-based. We use web technology for the BIM. BIM is building information modeling, is about processes for construction projects, processes about data and 3D models of buildings. So we develop common data environments and to manage projects for BIM collaboration, for centralized data. And so we have different themes and features about our platform. And now what we're working on, it's about rendering. It's a R&D project inside the company. We are a small company, we are 5. But this project is about to turn the 3D model, BIM model, in 3D rendering and with ray tracing. So we use 2 technologies to do that. The first one is Autodesk Forge, because we are experts in Forge. We are certified integrator. And this helps us to transform BIM models in different kinds of formats. And we use their 3D viewer, WebGL viewer based on 3GS. And the second technology is Vray from Chaos. It's a partner too. And Chaos furnished us their SDK. It's a ray tracing engine. And so we are integrators of these both technologies. And the objective is to prepare 3D scenes and have a real time between the clients and the server. So we did that. We use BIM, the BIM process to easily access to data. And we use also the latest web technology to prepare a web platform. So we use NoSQL database. We use a lot of MongoDB web database. And we use to discuss between the 2 systems and between the front and the back with WebSockets protocol. So the first thing to do that was to prepare models, because we have native BIM formats and like RVT, Revit file, or Revit format, or EFC, or Navisworks, and we need to transform the geometry for the Vray engine. So we used you created a connector between the two systems, and we use GLTF to store the geometry directly inside the server, because we need an easy format to store and don't store it in database. So the next step is about the platform. Because this use case, and we address the platform to architects, to BIM engineers, BIM managers, and we need to prepare a 3D scene to be directly processed by Vray engine. So we had to create some features, about the preparation of 3D scene. It's we aggregate models, we create 3D scene graph management, and we can use GPS localization to generate 3D environments, and we can assign materials, adjust camera, point of view, we can play with cutting planes, and most important things about the sun, the light, with ray tracing, because ray tracing is a rendering engine based on lights. So we can adjust the sun with date and hours. We can put directly in the scene different kind of objects from external libraries like Cosmos or BIM objects. And what we work on is about the optimization of a renderer. So it's a RESTful architecture with the front and the back end. Back end with the RTX GPU. For the demo, we use RTX 4000. And the two systems need to discuss, and we use HTTP request based on WebSockets. So we have a real-time process when a user manipulates the 3D scene. The result is close to real-time, because we used progressive rendering from Vray. And this is now the technology is impressive, because more your graphic cards is powerful, more you have the best fast rendering picture. And the problem we are working on is about the latency, because of more your data center is far, more you have that latency. In the demo we present after, the server is based in New York, so you have something like 100 milliseconds of latency, and more we are close to the position of the best is the renderer. So thank you. We passed in private beta in December with RPBW Architects, runs the piano agency, and we hope next year to have a public beta. Thank you very much.
So thank you very much for keeping the time. This is not easy, so thanks a lot. And thanks for the nice presentation. So next on stage, so overview of MPEG volumic applications by Ralph Schaeffer and Céline Guédé. So please, on stage. Please go ahead.
Yeah, thank you for the introduction. Yeah, I'm Ralf Schäfer from Interdigital, and this is a presentation on my behalf and my colleague Celine Gate, who prepared the demonstrations. So I work for Interdigital, and Interdigital is a research lab in wireless and also video, and we contribute to MPEG, and we have yesterday seen the work on volumetric codecs, and the use cases that I present here are related to that. So my use cases are more related to entertainment. So it's a little bit different from what we have seen before. So we go to volumetric video. So first some terms and factors. So we have 3DOF and 3DOF plus and 6DOF. And let's see what that is. So 3DOF is just 360 video. That means you can turn your head around, you can look up, you can look down. And this is the classical stuff, but often people get nausea, so it's not so interesting to look at that. There's a more sophisticated approach that is called 3DOF plus. That means you can really move in front, go back. You can really do some more movements. They have more flexibility. And then there's 6DOF that you can really move around an object like what I'm doing here, but of course just limited in space. You cannot move out of the scene. So just these different terms. Then basically we cover from the MPEG perspective two important use cases. So one is here the upper one, in fact, where the viewer is relatively close to an object and can look, and we can look at it from all sides. You see all the cameras around it. So these are used to capture this person in the middle. And later when you see content, you can really move around, take any camera position around it, and this looks pretty good. And you have the lower use case where the viewer is relatively distant. So you're sitting, for example, in a stadium, or you're down in the field, in fact, and yet that you can look around you and you can see not just in one direction, in fact. So there are two cases. The first one is covered by we call it the VPCC codec, so video-based point cloud compression. We have a demonstration for that one here. And the lower one is the MPEG immersive video, so the MAV codec, where we have also a demonstration here. And these are different use cases, but both are complementary. So first we will look into VPCC. So I think what a point cloud is. I go directly into the use cases. So the first one is an interesting one. That is 3D conferencing. We do that today. In fact, what we do with WebEx or with Teams, in fact, you see just a flat person in front of your screen. Here you would see really a volumetric person that you could move around and see much more. And you have the feeling that this person is real. The features that you need here is really a real-time capture. That means you need cameras that can capture that in a volumetric way. And also the encoding needs to be in real time. And of course, on the other side, you need to decode in real time and reconstruct it, that it looks really as a 3D image. But this is probably an interesting feature for the future and an interesting use case. The second one is the one which is more with what we call AR, so augmented reality. So the background here is coming from a camera, and this guy is a point cloud, and and you can move around it. And if you would move the device, really, you could really see this person from another side. So this demonstration, have it outside here. You can see what how it looks, and that it's, I think, pretty interesting. This one. And the third one that we have, it's more for a sports event that so you would look at this basketball match, and there's an interesting moment, and then you would be able to replay it back and see exactly, for example, how the guy is marking this goal. And you could, with an interactive interface, you could really say, okay, I would like to see it from this angle. Okay, how did the guy this ball in the basket? And you look at it from different angles, and then you just continue to view the content as you would have done it before. So there's some interesting feature for entertainment in the future that could be done with VPCC. Here you have some examples of point clouds that have been encoded. And you see we use around 800,000 points. But of course, this is per frame. And if you have 30 or 60 or more frames per second, the bandwidth quickly goes up. So here we would have 1.5 gigabits, in fact, which is quite a lot, so too much for our networks. And we need to compress it. And with VPCC, you can get it down to
5.6 megabits or even lower. So this is totally realistic even over DSL networks. So we have a ratio of around 300 to 1 that can be obtained. Here we used the HEVC video codec. So yesterday we explained how this is working, that we map it in a 2D space and use a classical 2D video codecs. If you would use VVC, which is the latest codec, you would gain another 30 to 40% on top of that. So it's pretty interesting. So the second one is the MIV applications. And here you have more the aspect, okay, that you are sitting on outside and you look at the field and you can really look around as you would be there. This is the aspect that MIV could do. So we have some demonstrations around that outside with a mobile phone. You can see this parallax. The second one is around a head-mounted device. We all know if you watch 360 video after some minutes, you get some headaches. In fact, this is really because, okay, it's not really adapted to your eyes. And with MIV, you can really do an individual rendering for each eye. And then it looks much more natural and you don't get, for example, this kind of headaches. So this is also an interesting feature of MIV. And the last one is really okay to have a classical flat TV set, but as a sort of light field display. So if you would go in front of that, because your eyes have not the same position, you would see the screen from a different angle and you would see it differently. That means really you would get this sort of 3D aspect back. And this is also possible with MIV because you can really do individual renderings for each eye, which is really an interesting feature. Yeah, that's it. I think this was quick. So I'm happy to see you outside for showing you the demonstrations. Thank you.
Thank you very much for the presentation, for this interesting presentation. Thank you for, again, being on time. And see you at the presentation afterwards. So next on stage, so the presentation will be performing art in the metaverse, how to open doors for artists and their fans. So I think we are lots of fans of artists probably around the screen. So this is by Gildas, Marius, and Cedric. Please, this is yours.
Okay, thank you very much. So first of all, I would like to thank Marius Preda and his team because we are here thanks to him. My name is Gildas Dussauz. I'm the founder of Virtuose. I'm not an IT guy, so it was really interesting what I see in the previous presentation, but I came with my CTO. So he's in charge of all the technical stuff. And what we are going to present you, it's our project. We are just now been selected by La Caisse des Dépôts to launch our metaverse. And this metaverse is dedicated to artists and to the fan. And this is what we are going to talk about. So at first, this is not what I'm saying. It's what the Wall Street Journal say. And it's saying that because no one go back in Facebook. Once you go one, you don't come back. So this is really an issue because they put a lot of money on the table to promote metaverse, but it's not attractive. So why? This is the main question. So this is how it looked like. Now, it's not a parody, it's like this. So this is Meta Talks Live. It's in Horizon World. And you have to imagine that you are totally immersed into this and you talk to those type of guy. And well, from my point of view, it's not attractive. And this is not the type of world that we want to live in, even if it's virtual world. at first, as I told you, I'm not IT. I came from the music industry. And what I'm really convinced of, it's what is simple and what is obvious, this can be adopted. When it's complicated, when you don't know why you are here, then it's not adopted. And this is why we think that the keys of this aesthetic and this utility of metaverse are in the hands of the artist. So our target is to let artists having access to this new type of territories and to welcome fans in those new virtual world. So for this, we are not developing specific technology. We are really focused on the interface, on the user experience, and we are integrating technos. So such as the one that Marius and his team is developing, but all type of technos that can be useful for the artists to have the better experience to live with their fans. So we made just a very short video of this. So this is where we are going to welcome people for the beta in a few weeks. So you have at first, I don't know why the video is as like this, but so this is our type of other avatars that we propose our user to use. So they're totally non-genic and totally neutral avatars. And in those space, we imagine to put places like this in order, for example, to expose NFTs in all the journey when they want to go and have access to what we call meta show. So meta show, it's so this is a short point of view of the lodge. So we are proposing a bit like a VR chat, a lodge of 20 people, and our target is to gather next year 50,000 people like this around 2 meta shows. So to achieve this, we have a very 360 approach. So we are thinking about what can be achieved on stage in a real theater, and what can be achieved in the virtual stage for the remote viewers. So at first it means having a total of experience with the capture, 3D capture. So for this, with Marius, we are experimenting his 3D capture videometric studio. The really interesting point with Marius is that it's a democratic studio. That means that it can be affordable in terms of price, and it has to be simple to use, because at the end of the day, we want the artist itself using the studio and not having the obligation to go through an engineer. Then we help artists to write, because writing a play, writing a show in an immersive environment is not at the same as on a virtual stage. So for this, they have to understand and the opportunities. They have to talk with engineers, but they have also to integrate the lean management system into their approach of creativity. So this is what we are calling residence. And we did the first one last year with the Théâtre du Châtelet, 2 artists, people from Télécom Sud Paris and other person. And we did it for 1 week, just to conceive a POC, a proof of concept of the first meta show. Regarding the user journey, it's an interface, web interface to buy a ticket. Then we are using an application. So this is the web interface. Then this is the application. I just show you the journey inside the application in the video. This application has been conceived on Unity, but it can be it can launch experience built with Unreal. And then regarding the physical stage, we imagine something that can gather people, real people in real places with virtual people, remote people. And this is what we are calling public fan zone or premium lodge that we want to implement in places like hotel. Well, with this, and thanks to the grant that we received from the government, the French government, we are now with a 3 years project with the main actors like Télécom Sud Paris, but also Théâtre du Châtelet, Ballet National de Marseille, La Scène Musicale, Insular Orchestra, and IRCAM. You saw only pictures in this presentation, but it's also about 3D audio journey. It's very important. The most impact effect of this type of experience is coming from the audio. This is with the audio that you can work with the presence. And I think that's all.
So thank you very, very much again for the presentation and being on time. Was also quite nice presentation. So next on stage, we will have geometry streaming on 40 Leadenhall Street. So a case study on the topic. So I call, I don't know who would present between Sébastien, Carmen, Mathieu, Max, and Joseph. So please, this is your turn. Thank you.
Thank you, and good afternoon, everyone. My name is Sebastian from 3D Repo. It's nice to be back at Web3D, even if only digitally this time, so fingers crossed for next year. In this use case, I want to talk about the importance of geometry streaming as a feature of modern BIM tools and how we at 3D Repo visualized the largest construction project ever to be granted planning permission in the City of London. So a little about us. 3D Repo is a building information modeling platform. If you've not heard that term before, building information modeling is concerned with managing the data about the real world built environment, so real world built assets. This is both during construction and after. So one very common part of BIM is the creation of 3D models, which, while originally would have just been models of the building that's going to be built, so these would be the actual way they were planned and designed, these are now becoming fully fledged digital twins afterwards, and they actually updated during the lifetime of the building. And these twins are reaching very, very high levels of detail in terms of, not just the spatial resolution of the models, but how they're used, tracking the state of various features and even occupancy. As more digital tools are used and the workload is spread between more contractors and specialities, these models are rapidly increasing in complexity, and this poses a big challenge for BIM tools. So in this presentation, I want to talk about 3D Repo's pursuit of infinite geometry streaming, a technique that we hope will one day allow continuous navigation in space and level of detail for BIM models. So in 3D Repo, multiple contractors on one project would load their models into our platform, and then these are federated together so that users have a complete view of the development at a point in time. So this is the purpose of our platform, is to combine data from multiple different sources, from multiple different workflows into a complete overview of a project. And the way that users typically explore this data is in 3D through our viewer, which is web-based. However, as these models grow, so does the difficulty of displaying them. So as models become larger and the number of elements increases, we very quickly exhaust first the number of draw calls in terms of the CPU time, which we've already exceeded a long time ago. We have to employ techniques like static batching nowadays to keep frame rates up. Then we exhaust GPU memory, and finally CPU memory. And the geometry and element count of models is constantly increasing. So the first reason for this is that more contractors are employing 3D tools, but also more manufacturers are making 3D models of parts available. So whereas before you might model a door as say 2 or 3 cuboids, nowadays a manufacturer will give you a very highly detailed model, hundreds of triangles, 5 to 20 different elements of different materials, and the architect will just drop these all over their model. So models of what would typically be the same size building are growing massively in complexity. And this is at the same time as firms want to increase the scope which these tools are used. So before you would model one building, now it's an entire development you want to model with that level of detail. So at 3D Repo, we're aiming to build a viewer supporting infinite scaling across these 3 dimensions: more models, more metadata, and more triangles, intended to allow continuous navigation across the development. Now in graphics, we already have various techniques that contribute to this, level of detail, imposter systems, etc. But putting this into practice is quite different. For one, our models come from many different sources, so we have to operate at a very low level. We operate over the internet, so there's very high latency between getting things on and off the GPU. And our platform, the browser, is fairly weak compared to modern native environments. So our main viewer, Unity, it's built in Unity, uses Inscription to cross-compile to WebGL, which limits our memory to 2 GB in the managed environment. It's a tiny bit more complicated because we can interop to JavaScript, but there are big limits, is what I'm trying to say. This is especially challenging when it comes to level of detail, because if you use static matching to keep the door counts low, this limits the spatial resolution of what you can stream on and off the GPU. So there's a trade-off between streamability and CPU overhead. So we are moving towards this goal in stages, and we're starting with the streaming of portfolio size models, and one such model is 40 Leadenhall. So 40 Leadenhall is a mixed-use development in central London. It includes almost 1 million square feet of space across 34 stories, and it is the largest construction project ever to receive planning permission in the city. This model far outstrips anything else on our platform. It has almost 2 million individual modeled elements, so that's 2 million individual components, each with their own metadata that users can see and interact with individually across over 100 gigabytes of source data. So to stream 40 Leadenhall, we start with a complete federation to the highest level of detail that the user would like to see. The model is clustered at the triangle level into blocks of uniform or approximately uniform size in memory, and then put into a tree based on their location. And at runtime, the viewer uses a priority queue to determine which blocks are most important based on their relative location to the camera, and also the amount of memory they'll take, the level of details, how much complexity you get for the size, or the memory usage you get for the size that the component takes up. And basically this process will run in a loop and fill all the available memory, where the available memory is computed dynamically based on other memory pressures. So viewer overhead and UI, of course, but also the metadata for the models themselves, which we also stream in and out. So what you're seeing now is the complete model of 40 Leadenhall streamed in using this system. I hope the camera path is preset, but everything else streams in real time. I hope that this is coming through very smoothly on the screen. It should be running at about 60 frames per second when it was captured. So this video itself is taken in Unreal, which is what we began prototyping in, because it presented a clean slate compared to our viewer. And we used this to answer questions such as how you break down the models into components that can be streamed in sensible blocks, but also how you communicate the state of the system to the user as this happens. Actually getting geometry on and off the GPU is really not the most significant part of a streaming solution. Because we operate over the web, we have to contend with very high latency. And this is a major challenge in user interface design. We use tree-based visualization to show outlines of both bundles and the individual model elements. And these serve to allow users to maintain orientation, but also confidence in what they're seeing or not seeing. You need to know if you see something that looks like it should have a component but it's missing, you need to know that's not in the model, it's not some failure of the streaming system. And we also use the clustering itself to aid in navigation for this purpose. So the algorithm takes into account the size of items. So we cluster very large, simple geometry together, and by implication of how the algorithm works, it's streamed in first. So it kind of provides a skeleton for users to use to navigate around. So once we proved this concept, we took it further and implemented it in our web viewer, which is built in Unity. We remodeled our primary model processing pipeline based on the setup that I just described, and use this to perform pre-generate Unity asset bundles, which is what Unity and the web uses as streaming in real time. And we tried to optimize our implementation using caching to the point where if users are inside a building, they won't see geometry stream in and out because it happens so fast on the periphery. And so our solution allows us to explore the 40 Leadenhall model seamlessly, even with highly constrained memory. And not just 40 Leadenhall, but we've used this technique in the web to visualize numerous portfolios of projects with multiple buildings such as oil and gas and even film studios. So geometry streaming, in conclusion, will be a necessary part of future BIM tools due to the explosion, not just in complexity, but in the scope at which users want to apply these tools. And we're taking one step at a time towards infinite geometry streaming, continuous navigation in space and LOD. And hopefully next year, I'll be back to show you even more in far more detail. So thank you very much for your attention, and I'll hand over to Matt, I think, next.
So thanks again also for being in time. So the session will finish a bit later. So we have the final presentation here from the session. So visualizing carbon in 3D repo from BIM to zero. Let's go. Mathieu?
We cannot have your microphone.
I'm sorry, I forgot to unmute myself. There we go. So following on from Sebastian's presentation, the AEC sector is facing one of the biggest global challenges to reduce overall carbon emissions on projects, which come with great environmental responsibility towards the built environment. So to look at that in detail, in 2020, the UN Environment Programme highlighted that the construction industry alone accounts for 38% of total energy-related CO2 emissions globally, thereby calling for a governmental urge to aggressively prioritise and implement material strategies that reduce life cycle carbon emissions. And so, therefore, we started to look at 3D Repo, and with our partners at Zero and some of our customers, how can we make embodied carbon visible on projects? So where cost overruns and program overruns are often in your face, you're seeing subcontractors' expenses go out the door, you're not seeing the same impact with carbon. So we took the 3D Repo platform, which, as Sebastian mentioned, is a web-based 3D model viewer tailored towards the construction sector. The key here is that 3D models are available at a URL endpoint, and we decided to build upon that to produce a streamlined 3D dashboard that pulled data in from external sources to display carbon calculations measured off industry standards. And the key here is that every country or every sector has a different process for calculating the carbon, and that's necessary because at the end of the day, the country and the government is the one that's going to audit your process to make sure that you've complied and your calculations are correct. So in doing that, we couldn't bring those calculations directly into 3D Repo. Instead, we have to integrate with third-party applications, pull that data in and match it up to the relevant elements in the 3D model. So the key there is using the metadata that's already baked into the 3D model from the authoring stage, and then tying the relevant calculations into those individual bits of data. We've then combined all that into an embodied carbon dashboard that's live on the web. The 3D model here is fully interactive, so you can rotate it around. You can click specific elements of the model, and then it will demonstrate to you. It will filter the rest of the data to show what particular elements are and what their carbon values are, and potentially the historical impact of those carbon values. So if you have done value engineering to reduce the carbon impact of particular elements, so like the slabs, for instance, on this model, you will see that in the graphic. So in terms of data consumption, as I mentioned, we take those take that data from third-party tools such as EC3, One-Click LCA, the ICE, which is the standard database here in the UK. We pull all that into 3D repo and relate it to the 3D elements. Those 3D elements can come from a variety of different places. Because we are a work-in-progress platform, we don't like to use necessarily file formats such as IFC, because they tend to be a handover file format. So we support native authoring file formats such as Autodesk Navisworks and Revit. Once those models are in 3D repo, you can either choose to visualize those inside the 3D repo app or push them out into Unity or Unreal. We produce Unity and Unreal assets from the models that are provided to us, and the data that's associated to them can then be read via our API in Unity or Unreal, inside the 3D application itself, or in Excel or Power BI, which is the demonstration we were doing earlier. And so what this allows is 3D technology enables data-driven approaches to cloud-based visualization to communicate material and emissions changes. So the key here is that anyone who isn't necessarily on board with or in the health and safety or the carbon emissions department can still visualize and understand their impact on the project. Interactive 3D BIM models accessed directly from the web browser reduce the barrier to entry. So we're no longer saying you have to download this desktop software, go and find the latest version of the models from your common data environment and push them in. And also all the data that anyone on the project visualizes in the web is also up to the minute. So you're not running the risk of someone looking at outdated data or data that's no longer valid. And then we can import the calculations here from the Institute of Structural Engineers, and you can see how that calculation is married up to that particular column with all the data there in the right hand side. And that's all key to being part of your carbon audit at the end of a project, to make sure that you have calculated your carbon in the correct way. So when we have buildings that claim to be net zero, we can actually audit them and make sure they are in fact net zero and it hasn't just been an error in calculation. And then what that means in terms of optioneering, over the course of the project, we can begin to tweak either our procurement strategies, potentially where we're getting this material from, how we are getting that material to site, and even how we are constructing the material. So it doesn't just have to be the design that changes to reduce the amount of carbon inside the project. It can be the logistics and the supply chain. And by being able to compare those over time, we can give the people on the project insight into how well they're performing, and also be able to measure KPIs to make sure everyone is on track. So if they've been given a particular deliverable, they can work towards it and monitor themselves against it. So in terms of benefits, we're hoping to reduce the impact of double handling of information. So rather than data being pulled down by one person and moving it to another, someone tweaking it and risking by the end of that process the information being incorrect, by taking it from the third party and pushing it straight into the model, we've got one source of truth. We want to improve the communication and visibility between pre-construction, design and the sustainability teams, so get everyone singing off the same hymn sheet. We think that by visualizing data, you can work towards improving the data, because if you've just got a block of data in a database or a spreadsheet, you may be operating under false assumptions and not even know it. But by visualizing that in a 3D model, you can start to assess whether your assumptions are correct and tweak your incoming data accordingly. We want to have better understanding in real time of the data and the carbon values inside your project. and including live carbon data monitoring throughout the life cycle of the building. So we're talking in large part here about the construction of the building, but post handover, that building then has to persist for 40, 50, 60 years and maintain a competent level of energy efficiency. And we hope to streamline the carbon validation process. So by having it as a hands-off process, it's all happening in the background so that no one person can be the bottleneck for a process which has a massive impact on not just the project, but also the other stakeholders such as the general public, the government, and the supply chain. So wrapping that up quickly, that is my presentation.
So thank you, Matt, for this presentation. This was the last presentation of this fast forward session. So thank you all to all the speakers to having made it possible more or less on time. So now I invite everyone to join, I would say, the interactive session that is outside the room here. I think this will be moderated by Christophe and Marius. Stay tuned also and come back for the awards at 5:30. So thank you all, and it was really a great pleasure to be with you the last 3 days. Thanks a lot, everyone.
Yeah, thank you, Alban. Great session, yeah, with a lot of content. That is, I'm very happy to see all these developments. It means that also what we are doing in research sometimes has an implication in the real world, and it's good to see that happening. Okay, so let's go in the exhibition hall and have access of all these demonstrations that were presented. It will be Darwin-based moderation. You go there, you choose the one you like, and you stay and ask people. So no one will guide you, but there are screens and you will see that on the screens. So we're back here in less than 1 hour, so at 5:30 for the closing ceremony.
On va l'arriver pendant 3 ans avec un peu vert. D'ailleurs, on enlève le vert. Ouais, on va parler, mais le design, ouais, c'est clair, il est produit de c'est un peu la cause. Ouais, je trouvais que
He's gone to the news area.